Now we are going to discuss one more important point, which is delta of n minus 4 is equal to delta of n minus 2. So why it is like this, we'll discuss now. So basically, as I've already told you, some important formulas I've already told you, which is delta of A into T is equal to 1 by mod A into delta of T, where A can be positive as well as negative. In this case, I've already told you. Then what is delta of AT minus B? So what I can do like this, I can take A as a common. So A minus B by A. Right. So this is my above formula. How do you write? 1 by mod A delta of P minus B by A. So this is what I can write. This is in the continuous time case. But now let's go for discrete time case. And delta of AN is always equal to delta of N. This is in the case of the discrete time domain. So A can be either positive or A can be even negative also. But then what is delta of AN minus B? So here also same thing. Take A as a common, N minus B by A. So if we apply the above formula, what we are going to get? Delta of N minus B by A. This is what we are going to get. So with the help of this concept, we can solve this question, right? What is the question we are given? Delta of 2n minus 4. So take 2 as a common, delta of 2 of n minus 2. So by the above formula, how can we get delta of n minus 2 I can write. So this is what we are going to get. So this is what we are going to get finally. So this is the thing that we are going to get here. Okay. So now let's go for the other points. X of n is equal to u of n plus u of minus n is a non-periodic signal. X of n is equal to u of n plus u of minus n is basically a non-periodic signal. So what is the meaning of this one? It is not a periodic signal. Very simple. You know what is u of n? So u of n is nothing but, you can say this is a graph of the u of n. So this is a graph of the u of n. And this is a graph of the u of minus n. U of minus n. Or simply, this is the continuous time case. So this is the u of minus t. Discrete time case means how we can write? Discrete time case means this is the u of n. So this is the u of n. And this is the u of minus n. So u of minus n is like this one. U of minus n is like this one. Suppose if we have these two signals, then what we are going to get? We are going to get in this fashion. So you are going to get like this. So you can see clearly at n is equal to 0, you are going to get its value is equal to 2. And remaining all the distance, you are going to get its value is equal to 1. So like this, we are going to get here. Right? So this value is equal to 1. So at n is equal to 0, its value is equal to 2. Because if you substitute x of n is equal to u of n plus u of minus n. So x of 0 is nothing but u of 0 plus u of minus n is nothing but u of 0 only. So u of 0 you know 1, u of 0 you know 2. So we are going to get 2. So therefore at n is equal to 0, its value is equal to 2. And remaining all the instant, its value is equal to 1. So the signal is not repeating anywhere. But it is not repeating anywhere. So we can say it is a non-periodic signal. What's the meaning of periodic signal? After some amount of samples of time, the signal should repeat. But in this case, it is not repeating. So definitely we can say it is a non-periodic signal or aperiodic signal. We can say in the simple words. Now let's go for the another point. Y of n is equal to sine of x of n square. Y of n is equal to sine of x of n square is a. So we need to comment on the linearity property. We comment on the time variant property as well as the non-causal property. All these things we need to cover. So let's solve this in a very detailed manner. Suppose what is the system they have given? Y of n is equal to, listen carefully, y of n is equal to sine of x of n square. So we need to comment what type of system is this one. Suppose if the input is x1 of n, if the input is x1 of n, what is the output? The output is y1 of n is equal to sine of x1 n square. Right? Suppose if the input is x2 of n, what is the output that we are going to get? Y2 of n is equal to sine of x2 of n square. Suppose if the input is x3 of n, what is the output we are going to get? Y3 of n. which is equal to sine of x3 of n whole square. Suppose if x3 of n is a summation of the two previous inputs, x1 of n plus x2 of n, then what is the output that we are going to see? Sine of. So x2 of n is equal to x1 of n plus x2 of n. So x2 of n square means radius n by n square. So we are going to get x1 of n square plus x2 of n square. Because x3 of n is equal to x1 of n plus x2 of n. So radius n by n square. Then we are going to get like this. So this is the y3 of n you are going to get. And what is y1 of n plus y2 of n? y1 of n plus y2 of n is nothing but sine of x1 of n square plus sine of x2 of n square. This is not, this you can't get it actually from y3 of n is not equal to y1 of n plus y2 of n. Then we can say it is a non-linear system. So non-linear system. So what is the meaning of this one? If it is if the input is a summation of two previous inputs and if the output is a summation of two previous outputs, then only we can say the gain system is a linear system. But in this case, it is not satisfying. So definitely we can say it is not a linear system. We can say it is a non-linear system. So definitely we say it is a non-linear system. Now let's check the time varying property or not. Time varying property that we are going to check. So for this, what is the input? So the input is x of n. So what is the output that we have got? Y of n is equal to sine of x of n square we have got. Suppose if the input is x1 of, suppose if the input is x1 of n, then what is the output we are going to get? Y1 of n is equal to sine of x1 of n square. Suppose x1 of n is that we have the previous input, then what you are going to get? Y1 of n is equal to sine of, x1 of n is equal to x of n minus n of. Let's see, x1 of n is equal to x of n minus n of. x1 of n square means radius n by n square. So we should get n square minus n of we should get. So this is nothing but x of n square minus n of we are going to get. Then what is y of n minus n of? If the input is divided by some amount of time, the output should also be divided by the same amount of time. It is an invariant system. So here y of n minus n of means replace by n by n minus n of. Then we are going to get sine of x of n minus n of whole square we are going to get. So like this we are going to replace n by n minus n of. So we are going to get like this. So if you see these two things, they are different, they are not same. So y1 of n is not equal to y of n minus n of. So this is a time varying system. If it is not, if it is equal means we can say it's a time invariant system. Invariant system means that the input is given by some amount of time, the output should also be given by some amount of time. Then only we can say the given system is said to be a time invariant system. Otherwise it's a time variant system. In this case, it is not equal. So we can say it is a time variant system. Then go for the causality. We are going to check the causality property. So how to check the causality property? Let us see here. So y of n is equal to sine of x of n square, right? So now substitute n is equal to minus 1. So y of minus 1 is equal to sine of, in substitute minus 1 square is equal to plus 1. So x of 1. So what is the meaning of this one? The output of the substitute n is equal to minus 1. So the output is going to depend upon which values of the input. At n is equal to minus 1, the output is going to depend upon which values of the input at x is equal to 1. At n is equal to 1. So therefore we can say that finally the present value of the output is determined on which values of the input. So the given system is said to be non-causal system. So the given system is said to be a non-causal system. So finally I can say I already proved that the given system is said to be non-linear system. The given system is said to be time varying system, as well as the given system is also called as the non-causal system. So these things always you have to keep in mind. So now let's go for the another point. Suppose if f of t is equal to f1 of t plus f2 of t. If f1 of t is a periodic signal, it is having the frequency of omega 1 to the time period of t1, and f2 of t is also a periodic signal, is having a frequency of omega 2 to the time period of t2. So if I do the summation, the resultant can be either a periodic signal or it cannot be periodic signal. And what I do in a continuous time case, whenever we are going to add two periodic signals, either you add or subtract the two periodic signals, the resulting signal it can be periodic or it can be non-periodic also. But in the case of discrete domain, whenever you add or subtract the two periodic signals, the resultant is always a periodic signal. I already told you. In the case of the continuous time signal, when you add or subtract the two periodic signals, the resultant signal, it can be periodic signal or it may be non-periodic signal. In the discrete time domain, when you add or subtract the two periodic signals, the resultant is always a periodic signal. So now, if omega 2 by omega 1, omega 2 by omega 1 is nothing but if you are going to get a rational number, means a number in the format of P by Q or P2 by P1. So omega 2 by omega 1 is nothing but if you simplify P2 by P2 by P2 by P1, then we are going to get either P1 by P2 or P2 by P1 if you are going to get a rational number. Any of these things, if omega 2 by omega 1 is rational, then definitely P2 by P1 is also rational. Then only f of t is a periodic signal and the Fourier series is going to exist for the signal f of t. So as I have already told you, therefore we can say if this is the case, then only f of t is a periodic signal and then the Fourier series is going to it is going to present for the signal f of t. So I have already told you, if this ratio is a rational number, then only we can say the given signal f of t, the given signal f of t will be a periodic signal. Then you can see, suppose P2 by P1 I have got like this. Suppose P2 by P1 I have got like this, which is m by k. M is integer and k is also integer. Then if you do the cross, m and k they doesn't have any factors. It doesn't have any common factors. Within m and k there is no common factor. Then the cross multiplication. So k into Q2 is equal to m into k1. M into P1. So this is called the resultant signal time period. So this is the signal time period. So here, if you do the ratio of P2 by P1, we are going to get finally a rational number m by k. M and k has no common factors. So if we do the cross multiplication, we are going to get k into Q2 is equal to m into P1. So this is for the resultant signal time period. So therefore, what is T naught is equal to m into T1 of k into T2. And if you know T naught, we can get omega 1 just put by T naught. Right? Omega 1 is equal to T by T1, omega 2 is equal to T by T2. So this point always you have to keep in mind. So I already told you, in the case of continuous time case, when you add or when you subtract the two periodic signals, the result signal can be periodic or it may not be periodic. And in the case of discrete time domain, if you add or subtract two periodic signals, the result signal is always a periodic signal. Suppose in this case, if the omega 2 by omega 1 is a rational, omega is periodic. Suppose if omega 2 by omega 1 is a non-rational, then therefore it is a non-periodic. Rational number is the same number in the form of P by Q, where P and Q are integers. Irrational means we can say that it is not in the form of P by Q. So now the next concept is h of omega is equal to y of omega by x of omega we got. So h of omega is equal to y of omega by x of omega we got. Then what is the phase delay of the system? The phase delay of the system that you have to remember, which is Ep at omega is equal to omega naught is equal to minus of phase angle of h of omega by omega at omega is equal to omega naught. What is the group delay of the system? Eg at omega is equal to omega naught is equal to minus b by b omega at a phase angle of h of omega. So this is called the group delay of the system. So these two formulas you have to remember. So let me explain in some more detailed fashion in this concept. So let me tell you in the detailed concept. Suppose if you take some LTI extension, the impulse response is h of t and the input is x of t. So what is the output? The output is y of t is equal to x of t combination of h of t. Similarly, you can see dv Fourier transform this one. So this will become x of w, x of omega. It will become h of omega and this is y of omega is equal to x of omega into h of omega. Right? And what is h of omega? H of omega is equal to y of omega by x of omega. Right? And what is the phase delay of the system? Phase delay of the system is equal to minus phase angle of h of omega by omega. The phase angle of h of omega by omega. So this is called as the phase delay of the system. Then what is the group delay of the system? Which is minus d by d omega of phase angle of h of omega. So this is the P. Suppose if a given signal is having a frequency of omega naught, So you have to substitute here. Omega is equal to omega naught. Here also you substitute omega is equal to omega naught. That's it. So this is for the phase delay of the system and PD is for the group delay of the system. So this one always you have to keep in your mind. So what is the phase delay of the system? Minus of phase angle of h of omega by omega, and the group delay of the system is called minus d by d omega of phase angle of h of omega. So if you remember this one, then easy to remember this one. Just d by d omega. That's it. D by d. Then everything is same. Just d by d omega. That's it. D by this keep numerical d and total d. So d by d omega. Remember everything is same. So this is for the phase delay of the system and is a group delay of the system. So the ABCD, it is going to come earlier. A, B, C, D, E, F, G. So G is going to come earlier. So G is going to come earlier than P. So PG, post graduation, shortcut remember is PG. So post graduation is the sequence. PG, post graduation. So in the G, there will be in the post graduation PG to remember. So PG to shortcut remember PG. Post graduation. So PP is equal to minus of phase angle of h of omega by omega. PG is equal to minus P by d omega of phase angle of h of omega. So this is the thing always you have to keep in your mind. At omega is equal to omega naught, you have to substitute. So PP is equal to phase delay of the system and PG is called as the group delay of the system. So these things always you have to keep in your mind. So therefore we can say TP is equal to minus of phase angle of h of omega by omega, and TG is equal to minus d by d omega of phase angle of h of omega. So these things always you have to keep in your mind. So TP is equal to minus phase angle of h of omega by omega, and TG is equal to minus d by d omega of phase angle of h of omega. So finally I can say for LTI system with the input response h of t, and if the input is x of t, then the output is y of t. Y of t is equal to x of t combination of h of t, and apply the Fourier transform function, everything we are going to get x of the Fourier transform is x of omega, and for h of t the Fourier transform is h of omega, and for y of t the Fourier transform is y of omega, which is equal to x of omega into h of omega. So h of omega is equal to y of omega by x of omega. So what is the phase delay of the system, which is minus phase angle of h of omega by omega, and the group delay of the system PG is equal to minus d by d omega of phase angle of h of omega. Substitute your omega naught for a signal which is having a frequency of omega naught. Substitute those values in order to get the phase delay of the system as well as the group delay of the system. Shortcut remember is PG. So PG means post graduation. First you are going to get the P, phase time, then you are going to get the group time. This is something always you have to keep in your mind. So phase delay of the system and the delay of the system that you are going to get here. So these things always you have to keep in your mind. So now what we will do? We'll go for the another point. So we now go for the other point. So these things always you have to keep in your mind. So all these things always you have to keep in your mind. So you can say if x of t is equal to 1 by 2 pi, integration of omega is equal to minus into x of omega into e to the power of j omega t into d omega. X of t is equal to 1 by 2 pi, integration of omega is equal to minus into x of omega into e to the power of j omega t into d omega. So d omega, right? So now what you will do? Very simply, x of t is equal to 1 by 2 pi, integration of omega is equal to minus into plus into x of omega into e to the power of j omega t into d omega. So now in place of t I will substitute 1. Then what you are going to get? X of 1 is equal to 1 by 3 pi into integration of omega is equal to minus into plus into x of omega into e to the power of j omega into d omega. So 2 pi do cross multiplication, we are going to get 2 point x of 1 is equal to integration of omega is equal to minus into plus into x of omega into e to the power of j omega into d omega. So here omega is a variable, so in place of t substitute 1. Suppose if t is a variable, means in place of omega substitute the values. So therefore this is what we are going to get. So this formulas always you have to keep in your mind. So listen carefully. For x of t, what is the Fourier transform? X of omega is equal to integration of t is equal to minus infinity to plus infinity x of t into e to the power of minus j omega t into dt. What is the inverse? So inverse Fourier transform, x of t is equal to 1 by 2 pi, integration of omega is equal to minus infinity to plus infinity x of omega into e to the power of j omega t into d omega. So these things I already told you. So the number of times. So x of omega is equal to integration of t is equal to minus into plus of t, x of t into e to the power of minus j omega t into dt, and x of t is equal to 1 by 2 times integration of over omega is equal to minus into plus of t, x of omega into e to the power of j omega t into d omega. So in place of t, if substitute 1, and if you do the cross multiplication, we are going to get this one, which is 2 x of 1 is equal to integration over the omega is equal to minus into plus of t, x of omega into e to the power of j omega into d omega. So now the next thing is, here h of omega is equal to y of omega by x of omega. The phase angle of h of omega is called as the phase response of the system. And then magnitude of h of omega is called the magnitude response of the system. So magnitude of h of omega, this is called as the magnitude response of the system. Magnitude response of the system. Magnitude response of the system. So these things always we have to keep in mind. So these things always we have to keep in mind. So we can say that as y of omega is equal to x of omega by h of omega, so phase angle of h of omega is called as the phase response of the system, and the magnitude of the h of omega is called as the magnitude response of the system. So these 2 points always you have to keep in mind. So therefore we can say the phase angle of h of omega is called as the phase response of the system, and the magnitude of the h of omega is called as the magnitude response of the system. This one I have told you so many number of times. So phase angle of h of omega is called as the phase response of the system, and the magnitude of h of omega is called as the magnitude response of the system. The next point is cos theta is equal to cos theta. You can write like this: cos square theta minus sin square theta, or 2 cos theta minus 1, or 1 minus 2 sin square theta. Because you know sin square theta plus cos square theta is equal to 1. So you know this formula, right? To substitute all these things, you are going to get like this: so cos theta is equal to cos theta minus sin square theta, or 2 cos theta minus 1, or 1 minus 2 sin square theta. By using the basic formula, sin square theta plus cos theta is equal to 1. So for this, so I'll take only this case. So cos theta is equal to 2 cos theta minus 1. So if you read this one, cos square theta is equal to cos theta plus 1 by 2. So cos theta is equal to cos theta plus 1 by 2. The next thing is, the next important thing is, suppose if x of t is having the x of t is a periodic signal which is having a period of t, and then it is having a Fourier series coefficient an. We can take an, or we take bn, or we can take cn. The concept is same. Suppose the signal y of t. So let me explain this one. Let me explain with the concept here. So let me write this part and explain in a very beautiful manner. I will try to explain. So give me 1 minute so that I can explain you this concept in a very detailed fashion, so that you don't have to remember all these crazy things. This concept I have already told you so many number of times, but let me again tell you so that you can easily able to understand what I am trying to tell you. Okay? So now I can say here, right? So now what I can say is very simple. This concept always have to be right? So therefore now you can say like this. Suppose if x of t is a periodic signal which is having a period of t, then it is having a Fourier series coefficient as an. Suppose x of t minus t naught, we will have the Fourier series coefficient I have already told you, which is a into e to the power of minus jn omega naught t naught. Omega t naught also we can take. Omega t naught we can take. Right? And omega naught t naught we can keep here. So now x of t plus t naught, we have the Fourier series coefficient a into e to the power of plus jn omega naught t naught we are going to get. Suppose if I add these two signals, so a of t is the summation of these two signals, x of t minus t naught plus x of t plus t naught. So what is the Fourier series coefficient? Just add these two things. So if I add these two things, what am I going to get? Which is an common e to the power of minus jn omega naught t naught plus e to the power of plus jn omega naught t naught that I am going to get here. So what I will do, say I will assume this thing I am going to assume, some bn I am going to assume, So if you simplify, what you are going to get? If you simplify e to the power of minus jn omega naught t naught plus e to the power of jn omega naught t naught, you are going to get 2 cos of n omega naught t naught we are going to get. So this is what we are going to get. sorry, just same thing we are going to get. So you are going to get like this. N is equal to 2 into An into cos of n omega naught P naught you are going to get. Okay. So now what I will do? I will do like this. Let I am going to assume let Bn is equal to 0 for n is equal to odd. Let Bn is equal to 0 for odd values of n. Yes, what is the meaning? For odd values of n, Bn is equal to 0. So this 2n is a constant, it cannot be 0. So only this function should be equal to 0 for odd values of n. For odd values of n. So what are the odd values of n? So you know cos theta. So see, cos function is going to get 0. So you know cos theta will have 0 for what value of n? For what value of theta? You know theta is equal to n plus 1 into pi by 2. So for these values of theta, the cos function is having 0. So now tell me the theta is equal to n into omega naught p naught. So n into omega naught p naught should have this value should be equal to n plus 1 into pi by 2. Then only we can say that we can say cos theta will have 0 values and theta is equal to n plus 1 into pi by 2. So these values of them we are going to get the value which is equal to 0, right? So n into omega naught p naught should be equal to n plus 1 into pi by 2. So suppose if I substitute n is equal to 1, then what I should get? If I substitute n is equal to 1, what I am going to get here? Suppose if I substitute n is equal to 0, I am going to get pi by 2. If I substitute n is equal to 3, n is equal to 1, I am say n is equal to basically n is integers. Right? So here basically n is integers. Or you can say take here k. Let us take k here. K is the integers, right? K is the integers. So we substitute k is equal to 0, then we are going to get pi by 2. We substitute k is equal to 1, we are going to get pi by 2. So like this. So n into omega naught p naught is equal to 0 for these values of theta. Right? So n into omega naught p naught, if this value is equal to either pi by 2 or 3 pi by 2, then the function we are going to get its value is equal to 0. So now let us assume. So by comparing, what we can say? By comparing, we can say that what is a common thing next to 5 pi by 3. Like this. So by comparing, what we can say? N is equal to odd and omega naught p naught is equal to pi by 2. So we can say like this, right? So what is omega naught? So omega naught, you know, 2 pi by 3 plus p naught is equal to pi by 3. So if we simplify, what we are going to get? P naught is equal to 3 by 4. P naught is equal to 3 by 4. So this is that P naught value, it should be equal to 3 by 4. And then we can say for odd values of n, for odd values of n, this phase coefficient is equal to 0. So if simple clearly, x of t is a periodic signal to the period of t, and it is having a phase coefficient a n. So x of t minus t naught as a phase coefficient a n into e to the power of minus j n omega naught p naught, and x of t plus t naught as a phase coefficient a n into e to the power of plus j n omega naught p naught. If y of t is a summation of these two signals, then the phase coefficient is a summation of these two things, and I am going to assume this is bn. So if we simplify this one, we are going to get bn is equal to 2 into n into cos of n into omega naught p naught. Suppose we can say that they have given the question that bn is equal to 0 for odd values of n. Odd values of n means n is equal to 1, n is equal to 3, like that. N is equal to 1, n is equal to 3, like this. But we know cos theta, they are going to get the value of 0 and theta is equal to 2k plus 1. Let us take 2k. If both are n, people will be confused. So here k is nothing but k. K is the integers here. K is equal to integers. K equals to pi by 2. So here substitute here theta is equal to n omega naught p naught. So theta is equal to n omega naught p naught. So n omega naught is equal to k plus 1 into pi by 2, where k is integers. So if I substitute k is equal to 1, I have got, suppose if I substitute k is equal to 0, then I got pi by 2. If k is equal to 1 means I am going to get pi by 2. If k is equal to 2 means I am going to get pi by 2, and so on. So by comparing those two things, what I can say, pi by 2 is a common, and remaining thing is the odd number. Here 1, here 3, here 5. So by comparing, what we can say, n is the odd number and omega naught p naught is nothing but is equal to pi by 2. So it's a pi by 2. So omega naught is equal to pi by 3. Omega naught is nothing but is a basically you can say x of t is equal to simply capital T. So its frequency is equal to omega naught, which is 2 pi by t. 2 pi by t. So omega naught is equal to 2 pi by t. Into t naught is equal to pi by t. So we simplify t naught, you are going to get capital T by 4. So when t naught is equal to capital T by 4, then the odd values of n, the Vn is equal to 0. So this is what I'm trying to prove. Same thing I have given, nothing I have changed. So for x of t, it is having the full coefficient as an. An is having the full coefficient of an with the difference of t. This is having the of t. If y of t is x of t minus t naught plus x of t plus t naught, for the full coefficient an and e to the power of minus j n omega of t naught plus an e to the power of j n omega of t naught, which is equal to bn, I am going to assume. So if you simplify, finally we are going to get 2n cos of n omega of t naught we are going to get. And the question I have mentioned, suppose bn is equal to 0 for odd values of n, means I have already told you cos function, cos 2 is equal to 0 for theta is equal to 2k by 7 to pi by 2 for odd integers, or k is equal to integers. So what you are going to get? I have already told you, so therefore n omega naught t naught. So theta is equal to 2k plus 1 into pi by 2 for k is equal to integers. Suppose if you substitute theta is equal to n omega naught t naught, and you substitute k is equal to 0, you get pi by 2. If k is equal to 1, is pi by 2. If k is equal to 2, we are going to get pi by 2. So by comparing, what is a common thing? Pi by 2 is a common, and the remaining terms are odd numbers. So omega naught t naught is equal to pi by 2 by comparing. So omega naught is nothing but 2 pi by capital T. So omega naught is nothing but 2 pi by capital T, means is a fundamental frequency of the signal x of t, which is 2 pi by t. And is equal to pi by 2. So if we simplify t naught, we are going to get capital T by 4. So these things always you have to keep in your mind here. So like this always you have to analyze. So now the next point that we are going to discuss is minus into u of minus t as a Fourier transform minus pi delta of omega plus 1 by j omega. So I will discuss in a somewhat detailed manner. So listen carefully. For u of t, I have already told you what is a Fourier transform. So let me write here. For u of t, what is a Fourier transform? I have already told you, which is pi into delta of omega minus, sorry, listen carefully. For u of t, what is the Fourier transform? Which is 1 by j omega minus pi into delta of omega. So this is the thing that we are going to get. So listen carefully. A small correction here. Just wait a second. There will be the correction. So this is the thing that we are going to get. So this formula we have to keep in mind. So these things always you have to keep in mind. Suppose in case if you forgot, so u of t. So what is the u of t? So what is the u of t? U of t, what is the Fourier transform? This one I have already told you. And the Laplace transform of u of t is equal to 1 by s. The Laplace transform of the u of t is equal to 1 by s. But Fourier transform will have some extra factor, which is pi into delta of omega. So these concepts I have already told you so many number of times. But still, you have to remember all these things. So always you have to remember all these things. So finally, you can say for u of t, what is a Fourier transform? So for u of t, the Fourier transform is very simple, which is you can say listen carefully. This is a plus only. This is the plus only. Just now I have checked it. So this is the formula. So 1 by j omega plus pi into delta of omega. So this is what we are going to get. So u of minus t means v plus omega by minus omega. Then what you are going to get? Minus 1 by j omega. Delta of minus omega is equal to delta of omega only. So pi of delta of omega. Because delta of minus omega is equal to delta of omega only. So like this you are going to get. So now again multiply by minus on both sides. So minus nothing but if you multiply minus on both sides, then what you are going to get? 1 by j omega minus pi into delta of omega. So minus pi into delta of omega plus 1 by j omega. Same thing, right? So same thing. So this is the minus u of minus t is nothing but the Fourier transform is minus pi into delta of omega plus 1 by j omega. So you have to remember the basic formula. For u of t, what is the Fourier transform? 1 by j omega plus pi into delta of omega. So u of minus t means 3 plus t by minus t means 3 plus omega by minus omega. So delta of minus omega is delta of omega. Do the multiplication of minus on both sides, and we are going to get 1 by j omega minus pi and delta of omega. So these formulas always you have to keep in your mind. So now the next point is 1 by pi t as a Fourier transform minus j into signum of omega. So 1 by pi t as the Fourier transform. So 1 by pi t as the Fourier transform minus j sigma of omega. This one I already told you. Then what is d by dt? So d by dt of 1 by pi t means I have already told you. D by dt of, say, f of t is the Fourier transform f of omega. Then d by dt of f of t has the Fourier transform j omega into j omega. So j omega into df of omega by d omega. So this concept I have already told you. The differential concept I have already told you. So these formulas always you have to keep in your mind. The differentiation, the integration, all these formulas always you have to keep in your mind. So therefore we can say the differentiation formula you have to keep in your mind. It is very simple, which is d by dt. So d by dt of f of t. So d by dt of f of t as a Fourier transform j omega into df of omega by d omega. Sorry. Then carefully, a small correction here. See, f of t has the Fourier transform f of omega. Then d by dt of f of t has the Fourier transform j omega into f of omega. Small correction. Whereas p into f of t has a Fourier transform j into df of omega by d omega. So these formulas you have to keep in mind. So d by dt of f of t has a Fourier transform j omega into f of omega, and t into f of t has a Fourier transform j into df of omega by d omega. So in this case they are doing d by dt of f of t is j omega into previous thing, which is minus j sigma of omega. So j into j is nothing but j square, j square is equal to minus, so minus 1 will become positive. So omega into sigma of omega. So sigma of omega, sigma of omega means, you can say like this, sigma of omega means here omega, here plus 1 and here minus 1, right? Minus 1. As you are multiplying by omega, then what it will become? It will become plus omega, and this will become minus omega. So minus omega, right? Minus omega you are going to get. So then how you are going to get it? So how you are going to get omega into sigma of omega? So how you are going to get? This is a graph that you are going to get, right? This is a graph. So how you can write like this? Omega for t greater than or equal to 0 and the minus omega for t less than or equal to 0. So simply we can write x is equal to mod omega, because mod omega is equal to plus omega for t greater than or equal to 0 and is equal to minus omega for t less than or equal to 0, right? So therefore we can say omega into sigma of omega is equal to plus omega for t greater than or equal to 0 and is equal to minus omega for t less than or equal to 0. Simply we can say this mod omega, because mod omega is equal to plus omega for t greater than or equal to 0 and mod omega is equal to minus omega for t less than or equal to 0. So this is nothing but mod omega you can write. So I am doing here mod omega. So as you can see clearly here. So d by dt of 1 by pi t. So 1 by pi is a constant, you can take it outside into differentiation. So t to the power of minus 1 is minus 1 and t to the power of minus 1 is minus 1 by t square. So minus 1 by pi t square will as the Fourier transform mod of omega you are going to get. So multiply by pi on the both sides. Multiply by pi. So multiply by pi on the both sides, then what you are going to get? Minus 1 by t square as the Fourier transform plus pi by plus pi, which is plus pi, right? Suppose if you are going to multiply by minus pi on the both sides, then what you are going to get? This is what we are going to get. So 1 by t square as the Fourier transform minus pi into mod of omega. So 1 by t square as the Fourier transform. So plus 1 by t square as the Fourier transform minus pi into mod of omega. So we can see clearly. So t to the power of minus 1 definition is minus 1 by t square. So minus 1 by pi t square as a Fourier transform mod of omega. So multiply by minus pi on the both sides. So if you multiply by minus pi on the both sides, then what you are going to get? So plus 1 by t square. So plus 1 by t square as a Fourier transform minus pi into mod of omega. As you can see clearly from this picture, right? So like this always you have to keep in mind. So now the next point is u of n, convolution of u of n is equal to n plus 1 into u of n. This one I already told you so many number of times. So u of n, convolution of u of n is equal to n plus 1 into u of n. So u of n plus 5, convolution of u of n minus z is equal to n plus 5 minus 8 plus 1 into u of n plus 5 minus 8, which is equal to, if simplify we are going to get n minus 2 into u of n minus 3. So this point we are going to get from the basic concept. So you know the basic concept, right? What is the basic concept? Suppose f of t convolution of h of t is equal to y of t you are going to get. Then f of t minus a convolution of the h of p minus b is equal to y of p minus of a plus b. So based on this concept, we are going to solve this one. So u of n convolution of u of n is equal to m plus 1 into u of n, that we already know. So let me assume this is y of n. Then u of n minus of minus 5. Convolution of the u of n minus a. So what is the thing we are going to get? So y of n minus of minus 5 plus h. So what is the thing we are going to get? Y of n minus 5 plus 8 is nothing but minus 5 plus 8 is equal to plus 3. So we are going to get like this. So y of n minus 3 is same thing. It represents n minus 3. So n minus 3 plus 1 into u of n minus 3. Right? So minus 3 plus 1 is nothing but minus 2. So n minus 2 into u of n minus 3. So this is what we are going to get. So n minus 2 into u of n minus 3. So this is what we are going to get finally. So based on this formula, f of p convolution of h of p is equal to y of p. So f of p minus a convolution of h of p minus b is equal to y of p minus of a plus b. Same concept is going to apply for this 10th case also. So by this we have got this value. So these things always you have to keep in your mind. So now the next concept is, see, e to the power of minus 5t into u of t, which has a Fourier transform 1 by 5 is j omega, because you know e to the power of minus 8 into u of t has a Fourier transform 1 by a plus j omega. 1 by j omega plus a you can say. So a is nothing but 5. E to the power of minus 8 into u of t has a Fourier transform 1 by j omega plus a is equal to 5. So now we are going to apply the duality principle. So duality principle means I already told you, if f of t has the Fourier transform f of omega, then capital F of t has the Fourier transform 2 pi into small f of minus omega. Right? So now here in place of omega, I have replaced omega by t. So 1 by 5 plus gt as a Fourier transform 2 pi into f of minus omega, u plus t by minus omega, u plus t by minus omega. So you are going to do the power of I omega into u of minus omega. So now what do we do? So this is what we are going to get. So replace t by minus t. So I already told you, if f of t has a Fourier transform f of omega, then f of minus t has the Fourier transform, which is f of minus omega. So as you are going to replace t by minus t, you also replace omega by minus omega. You are going to get 2 pi into the power of minus 5 omega into u of omega. So now what I will do? Both sides I will multiply by 1 by pi. If I multiply by 1 by pi on both sides, then I am going to get 1 by pi into 5 minus j2 as a Fourier transform 2 into the power of minus 5 into pi omega into u of omega. So this is what that we are going to get. So you want to remember only one thing. If f of t is a Fourier transform f of omega, then capital F of t is a Fourier transform 2 pi into f of small f of minus omega. This is called duality principle. And f of minus t has the Fourier transform f of minus omega. But if you want to memorize the general formula, then f of at has the Fourier transform 1 by mod a into f of omega by a. Where a can be positive, or a can be negative, or a can be any. A is greater than 1 means we can say the compressing in the time domain. A is less than 1 means it is expanding in the time domain. So this one I already told you so many number of times. And e to the power of minus 8 into u of t has a Fourier transform 1 by a plus j omega. So these things I already told you so many number of times. Suppose now, if x of z is equal to x of z to the power of minus 1 and z naught is a 0 of the x of z, then 1 by z naught is also is equal to z naught to the power of minus 1 is also a 0 of the x of z. So what is the meaning of this one? If x of z is equal to x of z to the power of minus 1, then and z naught is the 0 of the x of z, then 1 by z naught, which is nothing but z naught to the power of minus 1, is also a 0 of the x of z. So this formula always you have to keep in your mind. So these things always you have to keep in your mind. Because I have already told you this concept so many number of times, but still you have to remember all these things. So let me give you some idea. What is the meaning of this one? Suppose they are given in the question only they are given. Suppose if x of z is equal to x of z to the power of minus 1 they are given. And z naught is the 0 of the function they are given. So z naught is the 0 of the x of z plus x of z naught is equal to 0 they are given. Substitute here will also 0. So substitute z is equal to z naught. So x of z naught is equal to x of z naught to the power of minus 1, right? As x of z naught is equal to 0, so 0 is equal to x of z to the power of minus 1 naught. So from this we can say that both Z0 as well as 1 by Z0, both are the zeros for the function x of z, x of z. So therefore we can say that if Z0 is the zero of the function x of z, then 1 by Z0 is also zero of the function only when x of z is equal to x of to the power of minus 1. So this is a condition. If this condition is satisfied, then only this is the case. But not for each and every case. Suppose if x of z is equal to x of z to the power of minus 1, and if Z0 is a zero of the x of z, means x of Z0 is equal to 0. If this is the case, in case of z, I can write Z0. So x of Z0 is equal to x of z to the power of minus 1. If this value is equal to 0, then this value is also equal to 0. So therefore, we can what is the root here? 1 by Z0. If Z0 is the root of the x of z, then 1 by Z0 is also the root of x of z only when the condition is x of z is equal to x of z to the power of minus 1. And I already told you one important point. If f of s is equal to f of minus s, then we can say the given signal f of t is a given signal. Suppose if f of s is equal to minus of f of minus s, then we can say the given signal is said to be off signal. So this one I already told you so many number of times. So these things always you have to keep in mind. So these formulas always you have to keep in mind. Similarly, if f of z is equal to f of z to the power of minus 1, then we say the given signal is said to be even signal. Similarly, if f of z is equal to minus of f of z to the power of minus 1, then the given signal is said to be odd signal. This is in the discrete time case. So this one I already told you so many number of times. So from this what we can say, so whatever this given signal, it is basically even signal. So what I can say from this concept, I can say the given signal, whatever the signal they are given is basically even signal. So you can say clearly, if x of z is equal to x of to the power of minus 1, means the given signal x of n is an even signal, right? The given signal x of n is nothing but it is an even signal. So we can say conclude that the given signal x of n, which is nothing but it is an even signal. So finally, I can say that if f of x is equal to f of minus s, then we can say the given signal is said to be given signal. If f of s is equal to minus of f of minus s, then we can say the given signal is said to be odd signal. If f of z is equal to f of z to the power of minus 1, the given signal is said to be odd signal. If f of z is equal to minus of f of z to the power of minus 1, then we can say the given signal is said to be odd signal. So these things always you have to keep in mind. So now let's go for another thing. So this is a signal x of n they are given. It is a finite duration signal they are given. So if this signal is having some magnitude in the for n greater than or equal to 0 it has some magnitude, and for n less than or equal to 0 it has some magnitude, and in the remaining duration it is a 0. As x of n is a finite duration with a both sides sequence, so then the ROC is 0 less than moderate less than infinity. This one I have already told you so many number of times. Just now I discussed. Suppose if x of n is a finite signal, finite duration signal, and if it is presenting only for n less than or equal to 0, this you can say like this. N is lying from like this. I can say from 0 to some minus n0. I can say is presenting only in the where n0 is equal to positive value. Then what I can say, then what is the ROC? The ROC is, we can say that we are going to the ROC is, it is all z plane except z is equal to infinity. Suppose if x of n is a finite duration signal, which is having 0 less than or equal to n less than or equal to n0. Here n is not is a positive. So here n0 is a positive. Which it is presenting finite duration signal, then what we are going to get? Then we are going to get like this. So then the ROC is all over this z plane except 0. Just like this one. Suppose if the given signal is a finite duration signal, and if it is presenting like this, minus n1 less than or equal to n less than or equal to, here n1 and n2 are positive. n1 is equal to positive and n2 is also positive. Then in that case, the ROC is 0 to means except 0 and infinity, remaining all the things. This one I have already told you so many number of times. Even if you forgot, suppose if you forgot, let me assume like this. The x of minus 1 is, let me assume 1, and x of 0 is 1, and x of 2 is also, x of 1 is also 1. I am going to assume, because the signal is present in the Okay, n less than equal to 0 is present and n greater than equal to 0 is also present. Then what is x of z? X of z, we know sigma n is equal to minus infinity plus infinity x of n into 10 to the power of minus n. So if you substitute n is equal to minus 1, you are going to get x of minus 1 into 10 to the power of 1 plus x of 0 plus x of 1 into 10 to the power of minus 1. As all the values are 1, you are going to get z plus 1 plus 10 to the power of minus 1. If you substitute z is equal to 0, if you substitute z is equal to 0, then what you are going to get? X of z is equal to 0 is nothing but you are going to get 0 plus 1 plus 1 by 0, which is nothing but infinity. If you substitute it is equal to infinity, then we are going to get infinity plus 1 plus 1 by infinity is nothing but infinity you are going to get. So this is not defined for both x, that is equal to 0 as well as that is equal to infinity. So what is the ROC? The ROC is except the point circle and infinite circle. It is defined for each and every point in the S plane. So this is what we are going to get here. So therefore finally I can say that the ROC is except to point circle and infinite circle, the ROC is on over the S plane. Just by seeing the Z transform, we can tell the answer in a very fraction of second if we know the concept. So these things only I am trying to tell you. So this is a point always you have to keep in the mind. So these things always you have to keep in the mind here. So now let's go for the other point. X of t is equal to, if x of t is equal to mod of cos t plus mod of sin t is equal to 1. So this is a very basic definition that mod of cos t plus mod of sin t is always equal to 1. So mod of cos t plus mod of sin t is always equal to 1 here, always. So suppose if you have doubt here, you can see clearly. So suppose what is that? Cos function, you know, sin function, mod of sin t, mod of sin t is like this you are going to get. So like this you are going to get. So this is the mod of sin t. Right? What is the mod of cos t? Mod of cos t is like this one. So listen carefully. So let me draw. So let me draw like this. Okay, it is a shifted version. It is a shifted version by 90 degree. So shifted version means this you have to draw from here. That's it. So you have to draw this one from here. So listen carefully. Let me draw this picture in a very clear manner so that we can easily able to understand. So you can easily able to understand the concept. So let me draw like this. So let me draw. Only one cycle I will do only for one cycle. Only one cycle I will consider, not everything. So listen carefully. Only one cycle I am going to draw, but not everything. So that you can easily able to understand what I am trying to do. So this is the P. This is the P, right? So like this you are going to get. So this like this you are going to get, right? This is the pi by 2. This is P is equal to pi. This is a minus pi by 2. And this is equal to pi. Then the mod of cos is nothing but just you have to shift the signal by pi by 2. Because you know sin theta is equal to, cos theta. Cos theta is equal to sin of theta minus pi by 2. Or you can say, pi by 2 minus theta. Pi by 2 minus theta. So cos theta is equal to pi by 2 minus theta. Except you can give me pi by 2 minus theta. So what I will do, you know, basically like this you are going to get. So this is the thing that you are going to get. So like this you have to draw. So like this you have to draw. So like this you have to draw. So how can I write? I can write like this also. So cos theta is equal to sin of pi by 2 plus theta also I can write. Pi by 2 plus theta also I can write. So pi by 2 plus theta means sin of theta plus pi by 2. So pi by 2 plus sin is to cos. And pi by 2 plus theta, 90 plus theta, sin is a positive. So it's a plus theta. This is the advance. It is the advance. So advance the signal sin by pi by 2, then we are going to get the cos. So what are the signal? Advance signal by pi by 2. Pi by 2 means we have to start from here. Instead of starting from 0, I will start the signal from here. That's it. So we are going to get this cos theta. This is mod of cos t, and this is a mod of sin t. So if we add these two things, what we are going to get? See, one is increasing, the other is decreasing, right? So here 1, here it is 0. So definitely its value is equal to 1. So you can see here the value is 1, here also the value is 1, here the value is also 1. So here also the value is equal to 1. So this you can see clearly here, right? So like this you are going to get. So like this you are going to get, right? So here also the value is equal to 1. So now, here one is decreasing, the other is increasing. One is decreasing, the other is increasing. So if we have these things, we are going to get this function, we are going to get like this. So we are going to get its value. Suppose we take 5 by 4, theta is equal to 5 by 4. Cos 45 is equal to 1 by root 2, and sin 45 is equal to 1 by root 2. So we are going to get somewhat like this. I think this is a graph. This is a graph that we are going to get. So this is a graph, I guess we are going to get like this. Okay? So this is what that we are going to get. So this is the picture we are going to get. So mod of sin plus mod of cos is always equal to 1. Is always equal to 1. So this one always you have to keep in mind. So mod of sin plus mod of cos is always equal to 1. Because you know the table. So you know the table, right? From you know the table, right? So what is the table you know? And theta. So sin theta, cos theta. And this is only from 0 degree, 30 degree, 60 degree, and 90 degree. Sorry, 0 degree, 30 degree, 45 degree, 60 degree, and 0 is 0. 1 by 2, 1 by root 2, root 3 by 2, and this is 1. So this is 1, root 3 by 2, 1 by root 2, 1 by 2, and this 0. So if you see from 0 to 90 degree, so this summation is nothing but 1. And this summation is also equal to 1. But in this case, if we have these things, summation is not equal to 1, right? 1 by root 2 plus 1 by 2 plus root 3 by 2 is not equal to 1. So it is also not equal to 1. But let me tell you, this is not the exact graph, I guess. This is not the exact graph. But to these values, theta is equal to 0, theta is equal to pi by 2, theta is equal to pi, and theta is equal to minus pi by 2, and theta is equal to minus pi. These values are 1. But in the remaining thing, I think this summation is not equal to 1 as per my analysis. But I don't know why I written it is equal to 1. Sometimes it is 1, sometimes it is not also 1. This I have to check here. But I can tell you with my conceptual knowledge, this value is not always equal to 1. Only for certain values of theta, its value is equal to 1. And for remaining, it is not equal to 1. I can say this is for sure. Suppose the next point is y of t is equal to t by 1 plus x into t minus 1, x of t minus 1. So this is the input-output relation of a system they have given. So now we'll do some analysis. So I'll substitute t is equal to 1 here. Then what I'm going to get y of 1 is equal to 1 by 1 plus x of t is equal to 1 is 1 minus 1 is equal to 0. So we can say the present output is depending upon the past values of the input. So therefore the system has some memory. Now I want to check whether the given system is time invariant or time invariant. I want to check. So you know, suppose if the input is x of t, so what is the output that we are going to get? Y of t is equal to t by 1 plus x of t minus 1. Suppose if the input is x1 of t, then what is the output that we are going to get? Y1 of t is equal to t by 1 plus x1 into t minus 1. Suppose if the input x1 of t is the delay of the previous input, which is x of t minus t naught, then what is the output? I wanted to check, which is y1 of t. I want to check, which is t by 1 plus x1 of, say x1 of t, you know, x of t minus t naught. Then what is x1 of t minus 1? So v plus t by t minus 1. So we are going to get t minus 1 minus t naught. So we are going to get t minus t naught. So t minus 1 is t minus 1 minus t naught. So you are going to get x1 of t minus 1 minus t naught we are going to get. Sorry, x of is not x of, this is x1 of t minus c. x1 of t minus 1 is nothing but x of t minus 1 minus t naught. So this is output that we are going to get. But if the input is below the previous input, then output should be below the previous output. So what is the output should be t minus t naught. So t minus t naught is nothing but t is there, t plus t by t minus t naught. So t minus t naught by 1 plus x of t minus t naught minus 1. So if you see, the denominators are same, but the numerator is different. So definitely we can say this is a time varying system, because y1 of t is not equal to y of t minus t naught. So we can say the given system is said to be time varying system. So if the input is below of the previous input, the output should be below of the previous output, then only we can say the given system is said to be time invariant system. But in this case, it is not like that. So we can say it is a time varying system. Same thing we have written that. So what is y1 of t? Y1 of t is p by 1 plus of x of t minus t naught minus 1. So this is the same thing I've got, right? So this is the same thing. And what is phi of t minus t naught? Whether t is that equals t by t minus t by t minus t naught, we are going to get like this. So both are not same. So definitely the given system is said to be time varying. Same thing. Phi 1 of t, this is the expression, and y of t minus t naught, this is the expression. So both are not same. So we can say this is a time varying system. Then how we can say whether the given system is linear or non-linear? So definitely the input and output has the non-linear relationship. That is the reason we can say it is a non-linear. Or simply if you want to prove, how can I prove the input is x1 of t, then what is output? The 1 of t is equal to t by 1 plus x1 of t minus 1. Suppose if the input is x2 of t, then what is output? y2 of t is equal to t by 1 plus x2 of t minus 1. Suppose if the input is x3 of t, then what is output? y3 of t is equal to t by 1 plus x3 of t minus 1. But if the s3 of t is the x1 of t plus x2 of t, then what is x2 of t minus 1 is equal to x1 of t minus 1 plus x2 of t minus 1. Then what we are going to get the output? T by 1 plus x1 of t minus 1 plus x2 of t minus 1. Definitely, this y3 of t is not equal to y1 of t plus y2 of t. Therefore, we can say that is a nonlinear system. So, if the input is a summation of two previous inputs, then output should be equal to the summation of two previous outputs. Remember, we can say the given system is said to be linear. But this is not the case that we are going to get. So definitely we can say the given system is said to be a non-linear system. So now the next thing is, if x of n is equal to delta of n minus delta of n minus 2, then what is x of n minus 2? Replace n by n minus 2, that's it. Therefore we are going to get delta of n minus 2 minus of delta of n minus 4. What do you have to do? First we have to replace n by n minus 2, that's it. So this is what we are going to get. So now the next thing is, for u of t, what is the Fourier transform? I have already told you. Find delta of omega plus 1 by j omega. Just now we have discussed that. Find delta of omega plus 1 by j omega. So what is u of minus t as a Fourier transform? A plus omega by minus omega. So you are going to find delta of minus omega plus 1 by j into minus omega. So you know that delta of minus omega is equal to delta of omega because it's a even function. So find delta of omega minus 1 by j omega. So this is what we are going to get. So therefore, if f of t is the Fourier transform f of omega, then f of at is a Fourier transform 1 by mod a into f of omega by a. Here a can be positive or a can be negative. This one I have already told you so many number of times. So always remember, u of t as a Fourier transform find delta of omega plus 1 by j omega. This formula always you have to keep in your mind. So if you remember this one, getting your remaining thing is a very piece of cake. So u of t as a Fourier transform find delta of omega plus 1 by j omega. So this formula you have to keep in your mind. The next point is, what is the next point here? The next one is very simple, which is simply I can say that time scaling property. So time scaling property that we are going to discuss. Time scaling property in Fourier transform states that the compression in time domain is equivalent to expansion in the frequency domain. Time scaling property in the Fourier transform states that the compression in the time domain is equivalent to expansion in the frequency domain. So this is the thing, same thing just now we have discussed it. So just now let me explain the concept here. So you can see, suppose if f of t has a Fourier transform f of omega, then f of at has a Fourier transform f1 by mod a into f of omega by a. Suppose here a is greater than 1. A is greater than means compression of the time domain. So if a is greater than means the time domain frequency domain. A is greater than means compression in the time domain. So here a is greater than means omega by a plus 1 is less than 1, definitely you are going to get expansion here. Similarly, suppose if a is less than 1 means expansion in the time domain, then here it will be compression in the frequency domain. So very simple concept, right? So therefore, the compression in time domain will lead to expansion in the frequency domain, and the expansion in the time domain will lead to compression in the frequency domain, as you can see clearly from the formula also. So therefore, you can see that the compression in the time domain will lead to expansion in the frequency domain, and the expansion of time domain leads to compression in the frequency domain. So by using this basic formula, f of t has a Fourier transform f of omega, then f of at has a Fourier transform 1 by mod a into f of omega by a. A can be positive, a can be negative, a can be greater than 1, or a can be lesser than 1 also. If a is greater than 1, we can say it is a compression, and a is less than 1, we can say it is a expansion. So the compression in time domain will lead to expansion in the frequency domain, and expansion in the frequency domain will lead to compression in the frequency domain. And x of 0 is equal to limit z tends to infinity x of j. So this one I've already told you. Let me repeat the formula. So let me repeat the formula. Let me repeat the formula so that you can easily able to understand. Suppose this is in the Laplace domain and this is the z transform domain. So here f of 0 is equal to limit s tends to infinity s into f of s. Here f of infinity is equal to limit s tends to 0 s into f of s. So here we can say f of 0 is equal to limit z tends to, so that is equal to e to the power of s. As s is equal to infinity, z is also equal to infinity. So 1 minus z to the power of -1 into f of z. So if you simplify, what you are going to get? So if you simplify, what you are going to get? 1 by z is nothing but 1 by infinity is equal to 0. So you are going to get limit z tends to infinity f of z we are going to get. So here f of infinity is equal to limit here you can see here s is equal to 0. S is equal to 0 means what is z? Z is equal to 1. So limit z tends to 1. 1 more z to the power of -1 into f of z. So if we simplify, we are going to get what we are going to get? Limit z tends to 1. Here we can simplify z minus 1 by z. If substitute is equal to 1, we are going to get z minus 1 into f of z we are going to get. So if you see clearly, here what I have written, x of 0 is equal to limit z tends to infinity x of z. So this is the initial value case. So f of 0 is equal to limit z tends to infinity f of z. So x of 0 is equal to limit z tends to infinity x of z, which also we can write. So this is the initial value. So this is the initial value theorem and this is the final value theorem. This is the initial value theorem and this is the final value theorem. So these theorems always you have to keep in your mind. So these things always you have to keep in your mind. Right? So these are the points always you have to keep in your mind. So now the next concept that we are going to learn is the energy of the signals. Suppose the signal f of t, if it has the energy E, then f of minus at plus b has the energy which is E by A. So let me tell you this concept in a very detailed manner. Suppose, let me listen carefully. This concept I will tell you. First thing is, suppose f of t has a signal energy E and the power P. So f of minus t has the signal has the energy E as well as the power P. Similarly, f of P minus A, the signal is also have the energy E as well as the power P. Suppose f of at, this signal will have the energy which is E by mod A, and the power is say. So this statement you have to keep in your mind. See, whether you are reversing the signal or whether you are doing the time use of the signal or whether you are doing a time of the signal, by these things, the energy of the signal will never get changed, but only by the time scaling, the energy of the signal is going to get changed. Whereas the power of a given signal will remain same as it is, even though you are doing the reverse of the signal, or either you are doing the time shifting of the signal, or either you are doing the scaling of the signal. So this important statement always you have to keep in your mind. So therefore, the energy of the signal is not affected by the time reversal as well as the time shifting, while it is affected by the time scaling. Whereas the power of a signal is not affected by the time reversal or time shifting or time scaling. So f of at has the energy which is E by mod A, where A can be positive or A can be negative. So if you see the above statement, what they are given, f of t. So f of t has the energy E. Then what is f of t plus b? Basically you are doing the shifting of the signal. Shifting of the signal means it will have the same amount of energy E. So now you are doing this time scaling of the signal. So it means this is 80. So now what you are doing? F of minus 80 you are doing is equals to minus 80. So f of minus 80 plus b. Means what is the meaning? You are doing the time scaling. Time scaling you are doing is E by modulus of minus A. Modulus of minus A is equal to A. So E by A is the energy. So therefore this is the thing you have to keep in your mind. If y of t has the energy, then y of minus 80 is nothing but just A is equal to minus A. So E plus A by minus A. So mod of minus A is equal to plus A again. So E by A you are going to get. So this is the energy. So therefore, if f of t has the energy E, then f of minus 80 plus b has a signal energy which is E by A. So always you have to remember only these things. The energy of the signal is not affected by the time reversal as well as time shifting, but is affected by the time scaling. Whereas the power of the signal is not affected by time reversal, time shifting, as well as time scaling. If f of t has energy, then f of at has the energy E by mod A. A can be positive or E can be negative. So these things always you have to keep in your mind. So you can say, suppose if you are Compressing the signal means the energy will decrease. If I expand the signal means the energy will increase, because whenever you are doing the compressing of the signal in the time domain, the overall time axis is going to get decreases, so energy is also going to get decreases. If we are going to expand the signal means the time duration is going to get increases, so therefore the energy is also going to get increases. This is a very simple thing. By this logic we can say, if A is greater than 1 means we are compressing the signal in the time domain, so this value is going to get decreases. If A is less than 1 means we are expanding the signal in the time domain, this value is going to get increases, because the time duration increases means energy is going to get increases. So this is the shortcut to remember. So the next concept, this is a thing that you have to keep in mind. Suppose it's a rectangular pulse. It is having amplitude of A, but duration of 1 is t by 2 plus t by 2 means the width is t. Only for this duration is having amplitude of A and event time is equal to 0. So we are going to write here in the general format A into rectangle of t by t. T is nothing but it is in the time domain, and this capital is nothing but it is having a width t, and this A is nothing but its amplitude. So therefore this is the general way of writing. So small t means this is represented in the time domain. Capital T means it is having a width of capital T. And here A is nothing but amplitude. So this is the general way of writing. Suppose, let me explain the example. Suppose if this A value is equal to 2 and this P value is equal to 1, then now how we can write 2 into a rectangle of E by capital 1. That's it. So we can write 2 into rectangle of P. Like this we can write. This notation is just a notation, right? So the next point is, when the periodic signal multiplied by exponentially varying signal, then resultant is always aperiodic. When a periodic signal is multiplied by exponentially varying signal, then the resultant signal is always aperiodic. Yes, very simple. Suppose there is a sine omega t. So sine omega t is a periodic signal, right? Sine omega t is a periodic signal. So e to the power of vt into sine omega t is nothing but it is a aperiodic signal or non-periodic signal. This is the periodic signal. This is a periodic signal. So sine omega t is a periodic signal. E to the power of vt into sine omega t is a periodic signal, because the signal will never repeat. It will never repeat its waveform. So the signal will never repeat its waveform. That is the reason it is called as a periodic signal or non-periodic signal. Periodic signal means after a certain amount of time, the signal has to repeat its waveform. Non-periodic signal means the signal must not repeat its waveform. That is the meaning of the periodic signal or the non-periodic signal. Periodic signal means after a certain amount of time, the signal must repeat its waveform. Aperiodic means the signal is going to not get repeated. So now omega t is a periodic signal, whereas e to the power of vt into sine omega t is a periodic signal. Because e to the power of vt is a periodic signal and sine omega t is a periodic signal. So multiplication of one periodic signal and the aperiodic signal, the resultant is a periodic signal. So whenever you are going to multiply periodic signal with a periodic signal, the resultant is also a periodic signal. So this is something always you have to keep in your mind. The next point is invertible systems. For unique input, the output has to be unique. Then only invertible systems. I already told you what's the meaning of invertible systems. For every unique, if you are going to get a unique output, then only we can get the vice versa. For every unique output, you should get a unique input. Then only because the given system is said to be invertible system. So let us take here some system. Let me take this as some system. Yes. So the input is X and the output is Y. So now I am going to keep some invertible system for this system. Then for Y means you should get the X. Then only we can say the given system is said to be invertible system. Means for every unique input, if you are going to get a unique output, then for every unique output, you are going to get a unique input. So therefore, then that is the case we can say it is an invertible system. For non-zero input, if the output is 0, then the given system is said to be non-invertible system. Suppose for input is equal to -1, +2, +3. For all these things, if you are going to get the same output. So for non-zero input, if you are going to get the output of 0, so see, for all these inputs, you are going to get the same output. Suppose if the output is 0, we don't know what is the exact input. So therefore, we can say, suppose if I have given the resistance equal to -1, then I got the output as 0. But for output is equal to 0, I don't know what is the corresponding input. It can be -1, it can be +2, +3. So we don't know exactly what is the input. So definitely we can say this is a non-invertible system. So therefore, invertible system means for every unique input, if you are going to get the unique output, or for every unique output, if you are going to get the unique input, then in that case we can say the given system is said to be an invertible system. Or for every non-zero input, if you are going to get the output as 0, in that case we can say the given system is said to be non-invertible systems, because when many inputs are having the same output, So in that case also we can get the non-mutable system. So finally I can say for every unique input, if you are going to get the output as a unique, then only we can say the given system is said to be immutable system. So for non-zero input, if you are going to get the output as 0, in that case we can say the given system is said to be non-immutable systems. So now the next important point is, which is always natural process, time shifting and time scaling is followed in a discrete time signal, but not an unnatural method. As I already told you, basically, whether it is a time domain or the discrete time domain, continuous time domain or discrete time domain, always you need to follow the natural process, which is time shifting to time scaling. In the continuous time, you can follow the reverse, but you should be very, very precaution. But in the case of the discrete time domain, always you have to follow the natural method only. But I recommend you to follow natural method in both the continuous time domain as well as the discrete time domain, so that you will not get confused. Always natural process, which is time shifting then time scaling, is followed in the discrete time signal, but not an unnatural method. Natural method means first time shifting then time scaling. Unnatural means reverse, first time scaling and time shifting. So always, whether it is a continuous time case or discrete time case, I recommend you to follow only the natural method, which is time shifting then time scaling. Suppose the signal is f of n minus n by n. So I want to get the signal from f of n. So what I should do, listen carefully. F of n is there. So what I will do? In place of n, I will substitute n by l. In place of n, I will substitute n by l. So f of n by l I am going to get. Then in place of n, I will substitute n minus n. Then I am going to get f of n minus n by l is nothing but f of n by n minus f of by m by n. Then in place of n, I will substitute nl. Then I am going to get f of n minus n by l. So listen carefully what I will do. See, basically f of n is there, right? So f of n. So first I will shift the signal by m. First I will do the scaling the signal by nl. So y of n I am going to write this is f of n by l. So I am going to scale the signal by n by l. Then what I will do? I shift the signal by n units. So y of n minus n is nothing but in place of n substitute n minus n. So n minus n by l is nothing but f of n by l minus n by l. This is y of n minus n. This one I am going to assume this is p of n I am going to assume. So now what I will do again, I will basically do the scaling by l. So p of nl is replace n by nl. We are going to get nl by l minus n by l. L cancels. We are going to get f of n minus n by l. So this is a simple angle and this is p of n. So this is the thing that we are going to get. So what I did first, basically I have scaled the signal by 1 by n. Then I should the signal by n units. Then again I did the scaling by l units. So listen carefully. What I did basically, first I did the scaling by 1 by n units. Then I did the shifting by m units. Then again I did the scaling by l units. So this is what I did in order to get this one. So you can see clearly. First I did the scaling by 1 by n units. Then I shifted the signal by m units. And again I did the scaling by n units in order to get the signal. So delta of n is always equal to delta of n. The A can be positive, A can be negative. So this one I already told you so many number of times, right? See, I already told you, which is delta of A into P is always equal to 1 by mod A into delta of P. Whereas here, delta of An is always equal to delta of n only. Here A can be positive or A can be negative. Here also A can be positive or A can be negative. So this is the thing always you have to keep in mind. This is in the continuous time case and this is a discrete time case. So here delta of A is always equal to 1 by mod A into delta of P. Here A can be positive or A can be negative. And here delta of An is equal to delta of n. Here A can be positive as well as A can be negative. So these things always you have to keep in your mind. So you can say delta of n is equal to delta of n, where A can be positive or A can be negative. The next point is, if f of t is equal to e to the power of minus 80 into u of t plus e to the power of 80 into u of minus t, how I can write? How I can write very simple, e to the power of minus a into mod t. Suppose, how I can write very simple, right? I have already told, see, mod t is equal to t, but t greater than or equal to 0. And mod t is equal to minus t, but t less than or equal to 0. So therefore we can see clearly, for t greater than or equal to 0, and if this is going to be present, then it will become e to the power of minus a into t. For t less than or equal to 0, and if this is going to get present, so therefore If you replace multiply minus t, we are going to e to the power of at. So like this we can write here. So f of t is equal to e to the power of minus a into what is nothing but e to the power of minus at into u of t plus e to the power of at into u of minus t. So now we have to remember these concepts, which is integration of 0 to 2 pi by omega naught cos L omega naught t into cos k omega naught t dt is equal to 0. Here L and K are the positive integers and which are basically distinct. They are not same. Similarly, 0 to 2 pi by omega naught sin L omega naught t into sin k omega naught t dt is always equal to 0. And integration of 0 to 2 pi by omega naught cos L omega naught t into sin k omega naught t dt is equal to 0. See, one is cos and the other is also cos. Sin, see, cos, sin, or cos sin or sin cos, which is same. But L and K should be different, and they should do integration from 0 to 2 pi by omega naught with respect to time. Then only we can say its value is equal to 0. So I can say like this. See, sin of different frequency, suppose sin of and it also omega 1 and sin of omega 2. Similarly, cos of omega 1 into cos of omega 2 or sin of omega 1 into cos of omega 2 or cos of omega 1 into sin of omega 2, where omega 1 is not equal to omega 2, and if you do the integration over the one time period, its value is always equal to 0. This point I have already told you so many number of times. So therefore, when you have different frequencies, one is cos and other is sin, or one is cos, see, you can go for anything. The first term is either sin cos or the second term is also sin or cos. One is sin cos, cos sin, cos. But the frequency should be different. Then only if you do the integration with the product and if you do the integration over one time period, one is always equal to 0. So listen carefully what I am trying to tell you. So this is the first term, right? So this is the first term and this is the second term. So first term into second term over the one complete time period is 0 to 2 pi by omega naught. Its value is always equal to 0. Your first term can be cos or sin. Here it can be cos or sin. But the frequencies are different. Their frequency should be always not same. They should be different. Then only it is going to be happen. If they are same, its value is not equal to 0. They should be different. So if one is cos means the other is also cos. Here cos means again sin. If sin means here cos. The sin means here sin. But the frequency should be different. If they are same means it is not equal to 0. So therefore we can say that integration of sin omega 1 to sin omega t or integration of cos omega 1 to cos omega 2 or integration of sin omega 1 to cos omega 2 or integration of cos omega 1 into sin omega 2. If you do the integration of one time period, its value is equal to 0 and omega 1 is not equal to omega 2. Only under this condition only this value is equal to 0. If both are same, this value is not equal to 0. So you can see this is L and K, both are positive integers and are distinct. They should not be same. So integration of the one time period cos L omega naught t into cos k omega naught t is equal to dt is equal to 0. Integration of 0 to 2 pi by omega naught sin L omega naught t into sin k omega naught t dt is equal to 0. Integration of 0 to 2 pi by omega naught cos L omega naught t into sin k omega naught t dt is equal to 0. The L and K are the positive integers are distinct. So finally I can say whenever two frequencies are different and if you are doing the product, one is sin or the cos and the other is sin or their cos, and if you do integration of the one time period, its value is equal to 0. Both should be different frequencies. The next thing is integration of 0 to 2 pi by omega naught e to the power of j in omega naught t into e to the power of j k omega naught t whole conjugate is always equal to 0. So this also you have to remember. Integration of 0 to 2 pi by omega naught e to the power of jl omega naught t into e to the power of jk omega naught t whole conjugate is equal to 0. Here k and l are also positive integers and they are distinct. This is also same condition. So they are also same thing. They should not be same. So L and K are positive integers and distinct. So this is a thing that you always have to keep in your mind. So integration of the one time period 0 to 2 pi by omega naught with the power of JL omega naught t into with the power of jk omega naught t whole conjugate, its value is always equal to 0. Then the next point is, so what is the next important point, which is e to the power of j of omega naught plus 2 pi k into n is always equal to e to the power of j omega naught n. So why it is like this? If you do the simplification, what you are going to get? So let me do the simplification so that you can be able to understand. So e to the power of j of omega naught plus 2 pi k into n. So okay, you can write e to the power of j omega naught n into e to the power of j omega naught 2 pi k into n. So if you simplify, this value is nothing but simply we are going to get this value is equal to 1 we are going to get. This value is equal to 1 we are going to get. So finally we are going to get e to the power of j omega naught n. So therefore, what I am trying to tell you, see, if a signal, suppose one signal is there, is a discrete time domain. I am telling you only the case of discrete time domain. If one signal is having the frequency omega naught, and the other signal is having the frequency omega naught plus 2 pi k, then k can be integers. K is equal to integers, positive integers we are going to take, positive integers. So frequency can be negative, so we will go for the positive integers means omega naught plus 2 pi, omega naught plus 4 pi, and omega naught plus 6 pi. All the signals will have the same graph. All the signals are going to have the same graph. The graph is going to remain same. But this is not the case in the case of the continuous time domain. See, just remember that in the case of continuous time domain, different frequencies will have different graphs. But in the case of discrete time domain, when two signals they have a difference of frequency of 2 pi, then the graphs are going to remain same. So this is what I am trying to tell you. So therefore, you can say, in the case of continuous time case, different frequencies, the graphs are different. But in the case of discrete time domain, the signals are having a frequency difference of 2 pi, then their waveforms are same. So if a signal is having a frequency omega naught, and if the other signal is having a frequency omega naught plus 2 pi k, the k is equal to integers, positive integers, the discrete time domain, these both signals will have the same amount of graph. So this one you have to keep in your mind. The next thing is, unit impulse signal is neither energy nor power signal. I have already told you, unit impulse signal is neither energy signal nor power signal. I have already told you. What's the meaning of energy signal? Energy signal means where energy is equal to finite and power is equal to infinity. So energy signal means energy is equal to finite and power is equal to 0. Sorry. And the power signal means energy is equal to infinity and the power is equal to finite. Neither energy signal, neither power signal means both are infinity. So energy is equal to infinity and the power is equal to infinity. So in the case of unit impulse signal, both the energy and the power are infinity. So definitely we can say it is a neither energy signal nor power signal. This concept I have already told in your classes, so I request you to listen to class. Unit impulse signal is neither energy signal nor power signal. Because here energy is equal to infinity as well as the power is equal to infinity. That is the reason we can say it is neither energy signal nor a power signal. The next point is, time shifting time reversal will not change the energy, but only the time scaling is going to affect the energy. I have already told you. See, for the energy of a signal is not affected by time reversal as well as the time shifting, but it is going to be affected by only time scaling. So, if f of t has the signal of energy E, then f of t has the energy E by A. I have already told E by model. So, this is what to keep in your mind. So, if f of t has a signal energy E, then f of t has the signal which is energy E by mod A. A can be positive, A can be negative. So, this one, as I have already told you, so many number of times. Whereas the power of a signal is not affected by time shifting, time reversal as well as time scaling. So power of a given signal is not affected by time shifting, time scaling as well as a time reversal. This one I have already told you so many number of times. So energy of a signal is not affected by time reversal and time shifting, but it is affected by only time scaling. Whereas the power of a signal is not affected by time reversal, time shifting and also time scaling. The next point is, if h of n is a real and even signal, then f of j omega is also real as well as even. So what is the meaning of this one? I have already told you an important statement. So this is the time domain and this is the frequency domain. This concept I have already told you so many number of times. Suppose if the time domain signal is a real signal and it is even, then in the frequency domain it is also real and also even you are going to get. On the real part you are going to get and it is a purely even in nature. Suppose if the real signal is real signal and it is a odd signal, then in the frequency domain we are going to get a imaginary signal and which is odd in nature. Just replace this real by imaginary and here v plus real by imaginary, and remaining things are same. Here it is a even, here it is odd. Here v plus real by imaginary, here v plus imaginary by real. That's it. So here it is a even, here it is also odd. So this concept I want to tell you. So if you know the first two things, getting the others is a very piece of thing. So I want to give this concept. So if you remember the first two things, getting the others is a very piece of cake. So it may be basic concepts. So this one also I want to tell you a number of times. So I request you to remember the concepts. If you remember the concepts, everything is beautifully a piece of cake. So in the time domain, if the signal f of t is the real as well as even, in the frequency domain, the only real part is going to be present and which is even in nature. The time domain for the given signal is real as well as odd in nature. In the frequency domain, only the imaginary part is going to be present and it is odd in nature. Similarly, that if the given signal is the imaginary and even, means replace real by imaginary and replace this real by imaginary. Then replace real by imaginary and replace imaginary by real. And the remaining thing is same as it is. Here even means here even, here even means here even. Here odd means here odd, and here odd means here odd. Same as it is. Only these things we are going to replace. Only these things we are going to interchange. That's it. So in this case, if h of n is real and even signal means this case, then h of j omega is also real and even. So here also is also real as well as even. Only the real part is going to be present. So what I can say, suppose h of j omega, if you have only real part means I can assume real. Only the real part is there means I can say real even part of omega I am going to write. Then h of minus omega is happening. Here I am doing omega only. Then h of minus omega. H of minus omega is happening, h of omega only. So therefore both are same, right? So both are same. So h of minus omega is equal to h of omega in that case. So this is what we can say clearly here. See, sometimes they will write h of j omega, sometimes they will write h of omega. But it's a notation, right? It's a notation. So this concept always have told you so many number of times. So the next thing is, when h of t is equal to u of t, means the impulse response is equal to, when the impulse response is equal to the steps, when the impulse response is equal to unit step, then what is going to happen? Y of t is equal to s of the combination of h of t. Then what is y dash of t? I have already told you y dash of t means either you can do any one differentiate. X of the combination of h dash of t, or we can say, or I can say, or I can write also like this, or you can write x dash of t combination of h of t also you can write. But in this case I will take only this case. And you know, h of t is u of t, so h dash of u of t is something that, see, h dash of u of t is something that b by dt of u of t. So b by dt of u of t is something delta of t. So x of t combination of delta of t is nothing but x of t. So x of t. So now what you have got, y dash of t, you got x of t. Then what is y of t? Y of t is the integration of this one. Integration of this one. So integration of this one is nothing but integration of the input only. So y of t is the integration of the input. So here y dash of t is nothing but x of t. So integration of minus infinity to t, x of t dt. So what I am trying to tell you is very simple. So let me tell you what is the idea. Suppose if we take a system, this is basically an integrator, I can say integrator. Here the impulse h of t is equal to u of t. Why it is like this? Suppose if we give delta of t, then what is h of t? H of t is equal to integration of the delta of t, or it is the integration of the input. This is nothing but u of t. Suppose if the input is x of t, then what is the output? Y of t. Right? So y of t is nothing but integration of the input. So is equal to minus infinity to t, x of t dt. Right? So now, suppose I want y dash of t. So I want y dash of t. So y dash of t means I want to y dash of t is nothing but x dash of t combination of h of t, or you can write x of t combination of f dash of t. I already told you. So h dash of t means I already told you. H of t is nothing but u of t. So h dash of t means delta of t. So x of t combination of the delta of t is nothing but x of t. So what is the meaning of this one? Suppose if you take a ordered system, here I want the derivative of the previous one. Derivative of the previous one means here the impulse response should be equal to delta of t. Then only in that case we are going to get the output as a differentiation of the previous thing. The output is the differentiation of the previous output. So we can say for this system the impulse response h of t. For that system, the input response is delta of t, then this output is the differentiation of the previous output. So this output is the differentiation of the previous output. Suppose if you want this one, from here means we have integration of this one. So if you want this one means we have differentiation of this one. And if you want this one means we have integration of this one. And this is a simple thing now. If you want this one means we have differentiation of this one. If you want this one means we have integration of this one. Same thing we have discussed. So what is y of t? Y of t is nothing but integration of the y dash of t. Y dash of t is nothing but x of t. So integration of x of t we can write. And the next thing is u of at is always equal to u of t for a greater than 0, and u of at is equal to u of minus t for a less than 0. A less than 0. So why it is like this? Let us discuss here. Suppose see. So u of t. So u of t is nothing but the initial point. The initial point and the final point I'm going to discuss. Initial and the final position. Initial position and final position. Initial position as t is equal to 0 and final position as t is equal to infinity. Then what is u of a? Scaling. They are doing a scaling. Scaling means I can say you have to divide by the scaling factor 0 by a and infinity by a. Suppose if a is equal to positive. Suppose if a is equal to positive, then what we are going to get? 0 plus infinity. Suppose if a is equal to minus, then what we are going to get? This is 0 and this is minus infinity you are going to get. Right? If a is equal to positive means you are going to get 0 and infinity. If you are going to get a is equal to minus means you are going to get 0 minus infinity. So now tell me, u of at, if a is equal to positive, then what you are going to get? Same as it is. Same thing we are going to get, u of t only we are going to get. Suppose if a is equal to negative, then what you are going to get? This graph is nothing but u of minus t. So u of minus t. This is what I am trying to tell you. So therefore, u of at is equal to u of t for a is equal to positive, and u of at is equal to u of minus t for a is equal to negative. As you can see clearly, u of t has initial position at a 0, t is equal to 0 and final position t is equal to 50. So u of at is divided by a, so 0 by a and 50 by a. If a is equal to positive, it will become 0, it will become plus infinity. If a is equal to minus, it will become 0 and it will become minus infinity. So you can see u of at is equal to u of t for a is equal to positive. The graphs is same. U of t and this graph is same. And if a is equal to minus means this graph is nothing but the reverse of the time reverse of this graph. So therefore, u of a is equal to u of minus t for a is equal to minus. So finally, u of a is equal to u of t for a is equal to positive and is equal to u of minus t for a is equal to negative. So this is what I am trying to tell you. So now the next concept. What is the next concept? The next concept is simply we can say sinc of x. What is sinc of x formula? Sin pi x by pi x. This one I already told you. Sinc of x is equal to sin pi x by pi x. Then what is saw of x? Saw of x also I already told you. The sample version. Saw of x is equal to sin x by x. So these two formulas always you have to keep in mind. So saw of x is equal to sin x by x, and then sinc of x is equal to sin pi x by pi x. So by comparing this, what we can say? By comparing this, what we can say? Sinc of x is equal to saw of pi x. So saw of pi x, right? So here if you replace x by pi x, then we are going to this one. So sinc of x is equal to saw of pi x, you can say. So saw of x is equal to sin x by x, and the sinc of x is equal to sin pi x by pi x. So this you can say clearly. Suppose if x of t is equal to a into sinc of alpha t. Suppose if you have some function x of t is equal to a into sinc of alpha t, you have got. Then how we can expand a into sinc of alpha t is by this concept sin of alpha t by alpha pi, sorry, sin of pi into alpha t by pi into alpha t. Based on this concept, we can say sin of pi into alpha t by pi into alpha t. This is what we are going to get. Then what is the Fourier transform of this one? We are going to write. So what is the Fourier transform of this one? We are going to write. So let me prove this one so that you can easily able to understand what I am trying to tell you. So listen carefully. Listen carefully. I will try to explain. Suppose this is the signal. So this is the time domain signal. The signal is having a t by 2 here minus t by 2 here having. And the width is a. This is the signal x of t. Time domain. Suppose if to the Fourier transform, what we are going to get? Fourier transform, what we are going to get? Suppose is x of t. Then what is x of omega? So x of omega is for the area. Area is nothing but a into t. Sa. Let's go for the sa. Sa of omega into what is width? It is for t. Right? T by 2. Right? So now what I will do? I will apply the duality principle. So duality principle is area and this is omega by t. If I will decrease omega by t, then what I am going to get here? A capital T, saw of small p into p by p. What is the Fourier transform for this one? P pi into x of minus omega. This x of minus omega is nothing but x of minus omega is p plus p by t means p plus p by minus omega. So the even function there, so it is an even function. So here x of minus omega. As the given function x of t is an even function, so x of minus omega is also equal to, because x of t is equal to x of minus t. So x of minus omega is equal to x of omega, because the given signal x of t is an even signal. So here x of t is equal to x of minus t. So therefore here also x of minus omega is also equal to x of omega. So how we are going to get? So we are going to get like this. So if you multiply a into 2 pi, you are going to get this as 2 pi a. So you are going to get this is 2 pi a you are going to get. And here, so with this here, this is p by 2 and this is minus p by 2. And it is different with respect to omega. So this is how you are going to get. Suppose I want this value. Suppose I want this value to be, what I will do, so this is nothing but 80 into saw p into p by 2. So what I will do basically, as I already told you, sin of x is equal to saw of pi x, right? Saw of pi x. I already told you, saw of pi x. So what I told you, so here, what is the pi x? So pi x is nothing but p into p by 2. So by comparing like this, so I am going to compare these two things. What I can say, pi x is nothing but p into pi by 2. And what is x? X is equal to p into t by 2 pi. So here I will write here, sin of p into capital T by 2 pi I am going to write. So this is the, I can write either in this fashion or I can both are same. So if you see clearly, at into sin of p into t by 2 pi as a Fourier transform, this is the graph we are going to get. Suppose what I will assume, suppose if I assume T capital T is equal to 1. Suppose if I assume capital T is equal to 1 and alpha is equal to T by 2 pi. Suppose if I am going to assume like this, what is going to happen? Assume. So if I am going to assume what is going to happen, T is equal to 1 and alpha is equal to T by 2 pi. This T is equal to 1 means 1 by 2 pi. We are going to get. So substitute here, what we are going to get here? T is equal to 1 means what we are going to get here? So T is equal to 1 and alpha is equal to 1 by 2 pi. Then what we are going to get here? Simply, this is 2 pi a. 2 pi a. Take it 1 minute. For T I am going to assume it is equal to 1. And if capital T by 2 pi, I am going to assume its value is equal to alpha. So capital T is equal to 1, right? So 1 by 2 pi you are going to get. And what is 2 pi? And what is it? Take here 1 minute. I am a little bit confused. Okay, what I can say. So this will remain as it is, right? So this will remain. Suppose that I am going to assume T is equal to 1. If T is equal to 1 means I am going to get, what is the thing I am going to get finally? If I assume T is equal to 1, what I am going to get? A into sin of alpha t you are going to get, right? Sin of alpha t you are going to get, right? Because capital T by 2 pi I am going to assume alpha. So alpha to t you are going to get. So what is the Fourier transform that we need to draw the graph? So we need to draw the graph. So now, if I see, so this is the graph that we are going to get. So what is the graph here? This is a, what is pi into alpha? So pi into alpha is nothing but 1 by 2. So pi into alpha is nothing but pi by 2. Pi into alpha is nothing but 1 by 2. So when t is equal to 1 by 2, it will become 1 by 2 and it will become minus 1 by 2. Right? So 1 by 2 means I can write pi alpha also I can write. The minus 1 by 2 means minus pi also alpha I can write. Right? Here 2 pi a. So 2 pi a. 2 pi a means I can write like this, a by alpha. So why it is like this? 2 pi a, because 2 pi is equal to 1 by alpha. So 2 pi is equal to 1 by alpha, right? Alpha is 1 by 2 means 2 pi is 1 by alpha. So I can write a by alpha. So this is what we are going to get. So a into sin of alpha t, for this what is the Fourier transform? This p equal is a by alpha and it is having a here minus pi alpha plus pi alpha. So this is what we are going to get, right? See, this is a concept. If you know the concept, then this is a very peaceful of a. So You know this basic thing. So what I assume, this is you know, right? So what I assume sink of x is equal to sum of pi x. So pi x I have assumed this is a p by 2. From this I got the value of x. I have substituted here. So both are same. So for this I got this figure. So what I assume p is equal to 1 and 2 by 2 pi I have assumed alpha. Then p is equal to 1 means 1 by 2 alpha. So what is alpha? Alpha into pi. Alpha into pi into alpha is nothing but 1 by 2. So if I substitute these values, I got this one. I got this one, right? So here also I have substituted these values and I got this is 1 by 2, this is minus 1 by 2, and this 2 pi here. 2 pi is nothing but 2 by alpha I can get. And 1 by 2 is nothing but pi alpha, and minus 1 by 2 is nothing but minus pi alpha. So this is the overall picture you are going to get. Same thing I have drawn it here also. So solve this going to sink of alpha is nothing but here a by alpha, here minus alpha, here plus alpha. So even though you forgot this one, you can get that one because it's a simple piece of cake. The next thing is, if x of t is equal to a into rectangle of t by t, means it is having an arbit of a, period of capital T, means a plus t by 2 minus t by 2. That is the meaning of this. Just now we have discussed, right? For a into rectangle of t by t means is having a arbit of a, period of capital T in the time domain. Then what is Fourier transform? The Fourier transform is I already told you, which is area. What is the area? Area is nothing but a into capital T. A sum of omega into what is the width? It is equal to capital T. And what is the width by 2? Width by 2, right? So AT into sum of x is equal to sin x by x. So sine of omega p by 2 by omega p by 2. So from this into cancels, we are going to get 2a by omega into sine of omega into p by 2. So same thing. So 2a by omega into sine of omega into p by 2. Same thing we have got. So this is x of t representation. So you can say x of t representation. The time domain. The capital period of t. For time period of design width of t is having amplitude a. And the remaining period is equal to 0. So this is a general way of writing. So this two things always you have to keep in mind. So let me write these two formulas so that you can be able to understand. For a rectangular pulse, what is the Fourier transform? Area into sum of omega into width by 2. For triangular pulse, what is the A? For the Fourier transform, area into sum square of omega into width by 4. So this one I already told you so many number of times. So this formula always you have to keep in your mind because in the examinations you will get at least one from this one. So like this always you have to keep in your mind. So now we are going to discuss another concept which is 1 by j is equal to, so multiply and divide by j on the both sides and we are going to get j by j square is nothing but minus j. So minus j means 1 at an angle of minus pi by 2. So 1 at an angle of minus pi by 2 radians or 1 at an angle of minus 90 degree, or simply we can also write which is 1 at an angle of minus 90 degree or minus pi by 2 radians, or e to the power of j, theta is nothing but minus pi by 2. So e to the power of minus j, so e to the power of plus j, angle is minus pi by 2, so minus pi by 2. So this is what we have to keep in your mind. Suppose I have already told you if there is any complex number, like this, then what you can write? The magnitude is under root over a square plus b square at an angle of tan inverse of b by a, or you can also write which is under root over a square plus b square, or e to the power of j, angle is tan inverse of b by a. So you can write like this. To get this concept, we have written this one. The next thing is minus 1 by j. Minus 1 by j is nothing but simply multiply by j and divide by j. So you are going to get minus j by j square means plus j you are going to get. Plus j means simply we can say minus plus 1 and the face angle is pi by 2, or 1 into e to the power of j theta, theta is pi by 2. And what is cos omega naught t? Cos omega naught t is equal to half of e to the power of j omega naught t plus e to the power of minus j omega naught t, and sin omega naught t is equal to 1 by 2 j into e to the power of j omega naught t minus e to the power of minus j omega naught t. So these are the basic formulas. I know to explain because I have discussed this one so many number of times. So cos of omega naught t is equal to half of e to the power of j omega naught t plus e to the power of minus j omega naught t, and sin omega naught t is equal to 1 by 2 j e to the power of j omega naught t minus e to the power of minus j omega naught t. So you know the basic formula, right? So what is the basic formula? E to the power of j theta is equal to cos theta plus j sin theta, and e to the power of minus j theta is equal to cos theta minus j sin theta. So from this, what is cos theta? Cos theta is equal to e to the power of j theta plus e to the power of minus j theta by 2. And what is sin theta? Sin theta is equal to e to the power of j theta minus half e to the power of minus j theta by 2. So these things always you have to keep in your mind. So with the help of this concept, we have got this one. And what is u of t? U of t you can write like this, half plus half into sigma of t, we can write. Sigma of t means u of t minus u of minus t. So if you simplify, same thing we are going to, which is equal to u of t. So let me write this one. See, basically what I am trying to tell you is very simple. So let me write this one. So u of t is there. So u of t I want to write in terms of the even function as well as the odd function. So as I already told this f of t. So what is even function? Even function is nothing but we can say f of t plus f of minus t by 2. And what is odd function? Odd function is equal to f of t minus f of minus t by 2. So I will try to find only for even function means I will try to find for t greater than or equal to 0, and odd function means I will go for the t less than or equal to 0. So if you know one domain, you can get the other domain just by same by even and opposite by odd. So for t greater than or equal to 0, I will try to find what is the even value of the function. So f of t plus f of minus t by 2. F of t is nothing but u of t, and f of minus t is nothing but u of minus t by 2. This even part of the t. So let's go for the, suppose t is equal to 1, and what are you going to get? F of 1 is equal to u of 1 plus u of minus 1 by 2. So u of 1, 1, u of minus 1 is 0 by 2. So you are going to get 1 by 2. So for all the values, of t greater than or equal to 0, its value is equal to half. So even this same thing you are going to get. So therefore you can say f of t is equal to half for all the values of t, because if you know one range, the other range you can easily get them just in the mirror image with respect to the axis. So now I want to find what is the odd function. Odd function is nothing but f of t is equal to f of t minus f of minus t by 2. So now f of t is nothing u of t. So f of minus t means u of minus t by 2. So for t greater than or equal to 0, I want to find what is the odd function. So for t greater than 0 means u of, suppose f of 1. So f of 1 I want to find. So u of 1 minus u of minus 1 by 2 you are going to get. Right? So if you substitute, what you are going to get? U of minus 1 is 0 and u of 1 is 1. So 1 by 2 you are going to get. So you got 1 by 2. Similarly, what is f of 2? F of 2 is also u of t minus u of minus 2 by 2. Is also equal to half. So therefore we can say, so what I can say, so I am going to draw the graphs. So the even part and the odd part, both the things I am going to draw. So this is the even part and this is the odd part. So even part, this one just now we have got, this is 1 by 2. And the odd part also we have got, its value is equal to 1 by 2 in this case. So odd means already. Odd means very much. This is minus of. Even same as it is. So like this. So this is the graph here. So this is something more. How you can apply f of t? Finally I can write half all the time. F of t, how can I write? It is equal to half into sigma of t plus u of t minus of u of minus t. So this is half into sigma of t I can write. Half into sigma of t. So like this I can write. So finally what is u of t? U of t is for the even part plus odd part, which is half plus half into sigma of t. So this is what I am trying to tell you. So if you know the even part, then just to the mirror image you are going to get. So if you find this domain, within this domain is a piece of cake just to the mirror image. So try to find for t greater than or equal to 0 for the odd part, and odd means reverse just to the mirror image of this one. So this is what we are going to do. So finally I can say what is u of t? Half plus half into sigma of t. Sigma of t is u of t minus u of minus t. This you can see clearly here. So now, then a to the power of mod n, how we can write? Which is equal to a to the power of n into u of n plus a to the power of minus n into u of minus n minus 1. So why it is like this, we will discuss here. So listen carefully. A to the power of mod n, a to the power of mod n. So now listen carefully. Suppose if it is n is equal to 0, how you are going to get? Like this you are going to get, right? Suppose n is equal to 0 means you are going to get 1. n is equal to 2 means we are going to get a square. Then a cube. Like this we are going to get. Suppose n is equal to minus 1. N is equal to minus 1 means a to the power of mod of minus 1 is nothing but, sorry, this is a to the power of 1 a square. And then a cube, because n is equal to 1, n is equal to 2, n is equal to 0. N is equal to minus 1 means again we are going to get a to the power of 1. This is a to the power of 1. Again n is equal to minus 2 means a to the power of 2 we are going to get. So n is equal to minus 1 and this is n is equal to minus 2. So this is nothing but a to the power of n into u of n. So this is nothing but I want to find this thing also. So how can I get this from? This is a to the power of minus n into u of minus n minus 1. So because u of n. So u of n is going to start from n is equal to 0 and n is equal to infinity. And u of n minus 1. U of n minus 1 means add 1 to the initial point and the final point. So 0 minus 1 is nothing but minus 1. And the minus 1 is equal to infinity. And u of minus n minus 1 means we have to do this, we are dividing minus 1 on the both sides. So we can divide it by minus infinity. So you have to add plus 1, sorry. We have to add plus 1 here because n minus n naught. So p minus n minus n naught means I have to add 1 to 0 and infinity. So 0 plus 1 is 1 and infinity plus 1 is 1. Here minus means, here minus n minus 1 means you have to, so we see u of n as a position at n is equal to 0 and final position at n is equal to infinity. So u of n minus 1 means we have to add 1 for the initial position after the final position. So 0 plus 1 is 1 and infinity plus 1 is 1. U of minus n minus 1 means you have to do the scaling by minus 1, the initial point and the final point. So 1 by minus 1 is nothing but minus 1 and infinity by minus 1 is nothing but minus infinity. So what is the initial point now? Minus 1 and the final point is minus infinity. So therefore you have to multiply by a to the power of minus n into u of minus n minus 1. So this part is nothing but a to the power of n into u of n and this part is nothing but a to the power of minus n into u of minus n minus 1. So this point always you have to keep in your mind. So listen carefully. So how you can write, suppose a to the power of t is there. How you are going to represent this? A to the power of mod t is there. How you are going to represent a to the power of t into u of t plus a to the power of minus t into u of minus t. This is in the continuous time case. A to the power of t into u of t plus a to the power of minus t into u of minus t continuous time case. And a to the power of mod n is a to the power of n into u of n plus a to the power of minus n into u of minus n minus 1. So this is a thing always you have to keep in your mind. So a to the power of mod t in the continuous time, how you are going to write a to the power of t into u of t plus a to the power of minus t into u of minus t. In this time case, a to the power of mod n is a to the power of n into u of n plus a to the power of minus n into u of minus n minus 1. This concept I already told. So mod t is equal to plus t, but t greater than equal to 0, and mod t is equal to minus t, but t less than equal to 0. So listen carefully. Mod t is equal to plus t, but t greater than equal to 0, and mod t is equal to minus t, but t less than equal to 0. Similarly, mod n is equal to plus n for n greater than equal to 0, and mod n is equal to minus n for n less than equal to 0. So this is what I have replaced. Here positive means plus t, here positive means plus n, here negative means minus t, here negative means minus n. So this is a thing always you have to keep in the mind. So now the next thing is sinc of x. What is sinc of x? Sin pi x by pi x. So pi x is also equal to sin pi x by pi x. We have already told this one so many number of times. What is saw of x? Saw of x is equal to sin x by x. And what is sinc of x? Sinc of x is equal to sin pi x by pi x. So from this what I can say, sinc of x is equal to saw of pi x. Okay? Same thing everything. So saw of x is equal to sin x by x. Sinc of x is equal to sin pi x by pi x. By comparing this, what I can say, sinc of x is equal to saw of pi x. So now the next point is k into saw of k into p by 2. The Fourier transform is 2 pi by capital T, 2 pi k by capital T into gt of omega. This is you can say the rectangular pulse. It's a rectangular pulse with a period t. So this one I already told you so many number of times. It is standard one. Let me repeat this concept so that we can easily able to understand. So as I already told you, now it's a time domain. So this is a time domain. So this is a thing I've already told so many times, but it will repeat this one. this is t by 2, this is minus t by 2, and this is the time domain t. So, what is the Fourier transform of this one? The Fourier transform is nothing but area, A into capital T into sa of omega into, what is the width? It is t by 2. Suppose back to the duality, v plus omega by t. So, A into t into sa of t into t by 2. What is this one? So, 2 pi into x of minus omega. As x of t is equal to x of minus t, so x of omega is also equal to x of minus omega. So 2 pi into x of omega. Because x of minus omega is equal to plus omega. So how you are going to get? So this will become 2 pi a. This will become 2 pi a. This is t by 2. This is minus t by 2. With respect to omega, you are going to get. So this is with respect to omega that you are going to get here. So now what I will do? So now I will assume kt is equal to k. I am going to assume. I am going to assume kt is equal to k. I am going to assume. Then what I am going to get? Let us see here. So then what I am going to get? See, if kt is equal to k, then what I can write? What is it? K by t. So k by t is equal to a. K by t is equal to a. Right? So k by t is equal to a. I can write. Right? So k by t is equal to a. Or simply we can say a is equal to what I can write? A is equal to k by t. I can write, right? So a is equal to k by t. Or simply what I will try. See, basically, the standard function. What is standard function? Standard function, what is standard function? This is 1. This is t by 2. This is minus t by 2. And this is with respect to omega. Suppose this is standard function. How we can write? Gt of omega, which is having an amplitude of 1. This is gt of omega. But here 2 pi we are multiplying it. So how you can write this one? So this one you can also write in the format of the standard function. This is standard function. This is called gt of omega. Means the width is t and its amplitude is 1. So width is t and amplitude is 1. So this we can write in the format of this one by 2 pi a. 2 pi a into gt of omega. So what is a? A is nothing but k by t. So a is nothing but k by t. So 2 pi a is nothing but k by t. So k by t into gt of omega. So like this we can write. So like this we can write. So this is the gt of omega is having the width of t is amplitude of 1. So this signal I want to represent in this format. So the peak is 2 pi a. So 2 pi a into this one gt of omega. A is nothing but k by t because I was doing kt is equal to k. So what I can write here finally? So k into sa of t into t by 2 has a Fourier transform which is 2 pi into k by t into gt of omega. So this is what we are going to get. Same thing is under 2 pi by k into t into gt of omega. gt of omega is the t can is 1 for a time of capital T. So these things always you have to keep in your mind here. Now the next point that we are going to discuss is this point, which is sa of at is equal to f of t. Suppose f of t is equal to sa of at, then what is the maximum frequency which is going to present in this signal, which is equal to a? Because sa of x, what is sa of x? Sin x by x. So what is sa of at? Sa of at is nothing but sin of at by at. Sin of at by at. So the basic formula, sin omega t. So omega is equal to a here. So the maximum frequency is going to present in the signal is equal to a. So audio signal range, what is the audio signal range? It is from 20 Hz to 20 kHz. So basically, if any signal which is having in the range from 20 Hz to 20 kHz, then you can hear. Means a human being can hear. If it is less than this or it is greater than this one, the human person cannot hear. So this is the thing always you have to keep in your mind. So what is the audio signal range? It is from 20 Hz to 20 kHz. So if any person can listen only from 20 Hz to 20 kHz, not above or not below. If any signal is having a frequency less than 20 Hz or above 20 kHz, then he cannot hear. So the audio signal frequency range is from 20 Hz to 20 kHz. So this point always you have to keep in your mind. So generally a person can hear an audio signal in the range from 20 Hz to 20 kHz. The next point is The Fourier transform is well defined for only energy signals. So the Fourier transform is well defined for energy signals. So by using the direct formula, we can figure out the Fourier transform of any energy signal. I've already told you, basically, suppose if a given signal is an energy signal, then definitely the Fourier transform is a well-defined Fourier transform. Means we can with the help of direct formula. What is direct formula? The Fourier transform form, which is integration of t is equal to minus infinity plus infinity, x of t into e to the power of minus j omega t into d omega. With the help of that dt, that we can easily figure out the value of the Fourier transform. The Fourier transform is limited defined for only power signal. So by using indirect properties, we can figure out the Fourier transform of any power signal. So suppose if a given signal is a power signal, then the Fourier transform is a limitedly defined Fourier transform. So only for certain values of omega it is defined, but not for other omega. For other omega it tends to infinity. Then we cannot directly get the Fourier transform from direct formula. So with the help of properties, I've already told you that with the help of properties, you can get the Fourier transform for that signal. So Fourier transform is not defined for signals if it is not energy signal or not power signal. So this one I already told you, which is listen carefully. Let me conclude this concept here. So this is a signal. So this is regarding the Fourier transform. So suppose if the signal is an energy signal, suppose if a given signal is an energy signal, then what is the meaning of this one? The signal is, we can say basically, we can say that the signal is basically, we can say it is a absolutely integrable. When a Fourier transform is a well-defined Fourier transform, means it is defined for each and every value of the omega. Then by using the direct formula, what is direct formula? Direct formula is, x of omega is equal to integration of t is equal to minus infinity plus infinity x of t into e to the power of minus j omega t into dt. By using this formula, you can get the Fourier transform for the signal. Suppose if a given signal is a power signal, means it is not absolutely integrable, then the Fourier transform is called as a limitedly defined Fourier transform. Means it is not defined for certain values of omega. Means if you substitute those values of omega, it tends to infinity. So defined means you should get a finite value, undefined means you need to get a infinite value. So limited defined means only for certain range of omega is defined, but other range of omega is not defined, means it tends to infinity. Then we cannot use the direct formula. Then in that case, we cannot use the direct formula in order to get the Fourier transform for these power signals. But we have to use the indirect properties. So I have already told you so many properties. What are properties? Time shifting, time scaling, frequency shifting. Those properties I told you, right? So with the help of those properties, you can get these type of things. What is the best example of a power signal? The best example is U of t. So U of t is the best example. So U of t is the best example for the power signal, because the energy is equal to infinity and the power is equal to finite. So this is called as the power signal. And what is the best example of energy signal? It is equal to the power of minus at into U of t for a greater than 0. It is the best example of an energy signal. So for this, we can easily get it with the help of this one. For U of t is a power signal, we cannot get the Fourier transform for the signal with the help of direct formula, but with the help of properties, with the help of these properties, we can get it this one. Right? This one I already told you so many number of times. So now, then if it is not an energy signal or if it is not a power signal, then not defined. The Fourier transform is not defined. It's not defined. Listen carefully. If a given signal is an energy signal, then the Fourier transform is well defined. Means it is defined for each and every value of omega. Then we can use the direct formula, this one, in order to get the Fourier transform. The best example is e to the power of minus 18 to U of t. This is an energy signal. If the given signal is a power signal, then the Fourier transform is called linearly defined. Means for certain range of omega it is defined, but for the other omega it tends to infinity. Then we cannot use direct formula to get the Fourier transform, but we are going to use the indirect properties. By using the indirect properties, we are going to get the value of the Fourier transform. The best example is U of t. If the given signal is negative energy signal, negative power signal, then the Fourier transform is not defined. So let me give one example. So e to the power of minus at into U of t. This is energy signal. So what is the Fourier transform of this one? 1 by j omega plus a, right? E to the power of, you can say, replace t by minus t. So AT into u of minus t. Then what is the Fourier transform replace omega by minus omega? So minus j omega plus a you are going to get, right? I already told you this one, right? So now what I will do very simply. So what I will do very simply that suppose if I add these two things, then what I am going to get e to the power of minus at into u of t plus e to the power of at into u of minus t. So if I add this one, I have to add these two things also. So what I am going to get finally a plus j omega plus a minus j omega. So 2a by a square plus omega square we are going to get. Suppose if I subtract e to the power of minus at u of t minus e to the power of at u of minus t, if I subtract, then I have to subtract these two things also. Then in that case what we are going to get is if the subtraction we are going to get 1 by j omega plus a minus 1 by minus j omega plus a means here we are going to get minus j omega plus a minus j omega minus a by a square plus omega square. So this is cancels. So we are going to get minus 2 j omega by a square plus omega square you are going to get. So this is what I have already told you. In place of a, if you substitute 0, then what you are going to get here? In place of a, if you substitute 0, in place of a, so if you substitute this one, in place of a, if you substitute 0, what you are going to get? U of t minus u of minus t. For this one, what is the thing that you are going to get? Simply minus 2 j omega by omega square. It is nothing but minus 2 j by omega you are going to get. U of t minus of u of minus t. So this you can say this is what we are going to get. U of t minus u of minus t has the Fourier transform which is minus 2j. So u of t minus u of minus t is something like this you are going to get, right? So this one and this one. This is a plus one and this is a minus one. So definitely we can say this is power signal because the energy is equal to infinity. So definitely we can say it's a power signal. So this is a power signal. So this we got Fourier transform. So for omega is equal to 0. So this one for omega is equal to 0. That's a Fourier transform is equal to infinity. So what I am trying to do is very simple. See, this is the energy signal and this is also energy signal. So for this energy signals, with the help of direct formula, we got this Fourier transform. But if you simplify this one, if you do subtraction of these two things, we have got this one. If this is suppose in place of a, if I substitute 0, then I got this one. Then also a in place of a I substitute 0, then I got this one. This is something signal function. So like this, you are going to get this is something like power signal because energy is equal to infinity and the power is equal to finite. So we can say this is called as a power signal. So for this power signal, we can say that I've already told you for power signal, we cannot get the Fourier transform by using back to formula. But with the help of these properties, we have got this one. With the help of properties only, we have got this Fourier transform. This minus 2j by omega. So if you substitute omega is equal to 0, this tends to infinity. So that is the reason this is called as a limited defined Fourier transform because it is not defined for each and every value of omega. So finally, I can say that if a given signal is called as an energy signal, means it's absolutely invariable, then the Fourier transform is well defined for each and every value of omega, and with the help of direct formulas, we can get the corresponding Fourier transform. But if a given signal is a power signal, means it is not absolutely integrable. In that case, the Fourier transform is a well defined, limited defined Fourier transform. So only for certain amount of omega it is defined. For other range of omega, it is undefined, means it tends to infinity. Then we cannot use the direct formula, but we have to use the indirect formula in order to get the value of the Fourier transform, just by using the properties. If a given signal is negative energy signal or negative power signal, then the Fourier transform is not defined. So these things you have to keep in your mind. Same thing I have written here. So Fourier transform is well defined for only energy signals. So by using the direct formula, we can see what the Fourier transform for any energy signal. Fourier transform is limited to defined for only power signals. So by using the indirect properties, we can figure out the Fourier transform of any signal. I have already told you that indirect properties. By using these properties, we can get this one. Fourier transform is not defined for signals if it is not an energy signal nor a power signal. This one I have already told you. The next point is, at low frequencies, the value of z is always equal to 1. At higher frequencies, the value of z is equal to minus 1 in a Z plane. So this you need to remember. So this one you have to keep in your mind. So finally I can say, at low frequencies, the value of z is always equal to 1. And at high frequencies, the value of z is equal to minus 1. You have to keep in your mind. So at low frequencies, the value of z is equal to, we can say, at low frequencies, the value of z is equal to 1. And at high frequencies, the value of z is equal to minus 1. But I have already told you what is the value of z. Z is equal to e to the power of s. E to the power of s. I already told you that s is equal to sigma plus j omega. Sigma plus j omega. Suppose low frequencies means we can say, let me also s is equal to j omega. I am going to write here. If substitute omega is equal to 0, then what is the value of z? That is equal to 1. High frequencies means omega is equal to infinity. In that case, what you are going to get should get z is equal to infinity, but here they are given minus 1. So you have to remember this one. Okay? I want you to remember this one because I also don't know how we got this one. So I want you to remember at low frequencies the value of z is equal to 1. At high frequencies the value of z is equal to minus 1. So finally I can say in the z plane, at low frequencies the value of z is equal to 1. And at high frequencies the value of z is equal to minus 1. Actually I also don't know how we got this one. But until that time, I want you to remember these two things. So at low frequencies, the value of z is equal to 1. And at high frequencies, the value of z is equal to minus 1. So finally, I'll tell you one important formula. Out of this, I'm going to calculate the everything. So the expression of the energy in a continuous time domain for a signal f of t is integration of from t is equal to minus infinity plus infinity mod of f of t whole square dt. If you want to write in the frequency domain, which is 1 by 2 pi into integration of omega is equal to minus infinity to plus infinity mod of f of omega whole square into d omega. So this is the continuous time case, and this is also continuous time in the Fourier transform. If you want to write the expression of energy in the discrete time domain, then sigma n is equal to minus infinity plus infinity mod of f of n whole square. We can write in this one also 1 by 2 pi. But you have to do only the integration over the one time period, which is 0 to 2 pi only you have to do integration from omega. This mod of f of e to the power of j omega whole square d omega. Because I've already told you that f of omega is in the continuous time Fourier transform, and f of e to the power of j omega, sometimes they also use f of omega. Sometimes they use e to the power of j omega, or sometimes they use, see, I've already told you, in some books, in the continuous time case, they will use either f of j omega, or sometimes they use f of omega. Similarly, the discrete time of Fourier transform is a continuous time Fourier transform, and the discrete time Fourier transform, sometimes they are going to use f of e to the power of j omega, or sometimes they are going to use f of omega also they are going to use. Okay, this is up to you. So finally, I can say in the continuous time case, I can tell you the expression of energy is equal to integration of t is equal to minus infinity mod of f of t whole square dt, or 1 by 2 pi integration of omega is equal to minus infinity mod of f of omega whole square d omega. And if I want to do the expression of the energy in the discrete time case, which is E is equal to sigma n is equal to minus infinity mod of f of n whole square is equal to 1 by 2 pi integration of omega only for one period of 0 to 2 pi mod of f of e to the power of j omega whole square d omega. See, basically here in the case of continuous time case, continuous time Fourier transform is a non-trivial signal, so you have to do the integration from omega is equal to minus infinity to infinity. But in the case of discrete time Fourier transform, this is a periodic signal, so you have to do the integration over only one time period, which is 0 to 2 pi only. Omega is 0 to 2 pi. In some books, like continuous time Fourier transform, they are going to use f of omega or f of j omega. The discrete time Fourier transform, some books they are going to use f of omega or f of e to the power of j omega. And the concept is same. So these things always you have to keep in your mind. So by this lecture, successfully, we have completed all the formulas of the signal and system in a very, very detailed manner. And if you like the content of our channel, then please to like, share and subscribe our YouTube channel. And don't forget to press the bell icon button. So whenever you upload a new video, direct news comes to your mobile. If any improvements in our lectures, then please look in the comment section. We'll definitely include all those videos in the coming lectures. Thank you so much for watching this lecture. Please smile, take care, and bye bye.